This conference will now be recorded.
Okay, so all right, so we are working with stats now, right? And statistics is basically a branch of mathematics, right? It's a branch of mathematics which deals with analysis of data, right? So any kind of analysis of data that you do, okay, any kind of analysis of data that you do is done using is done using statistics, right? And there are various, yeah. So where there are various forms of statistics, there are various steps that you take whenever you kind of do any analysis of data, right? So any analysis of data that you ever intake, or rather any kind of business problem that you solve, right? Uh, you always try and understand the business problem, correct? Understand the business problem. Once you have the business problem in place, the data collection would happen, and once the data collection is in place, once you have the data with you, you would want to analyze this data, right? So analysis of data would happen, and in this third step, which is analysis of data, wherever you're doing any kind of analysis of data, you would need statistics, right? There are multiple forms of statistics, multiple types of data that we deal with, and since we deal with different types of data, the kind of analysis that you do on each of the data is different. Okay, so I'm sure some of you would know about this, some of you might not be aware. So although we have kind of talked about it in some of the other sessions as well, uh, so there are, the data can be divided into multiple forms, based on the type of data can be in multiple forms, can be divided into various ways, right? Different parameters on which it can be divided in terms of, the way the data is. So it can be in structured or an unstructured data. It can be a continuous or categorical data. It can be a nominal data, right? So different kinds of data will be there. Um, when you are trying to do data analysis, continuous data will be treated differently and categorical data will be treated differently, right? These are two major uh, forms in which the data division is happening, right? I'm sure most of you know about it, continuous and categorical, but I'll quickly reiterate. Continuous data which is generally numeric in nature. Okay, and when you talk of numeric data where basic numerical analysis would make sense, right? So if I perform, say, average of that number, it will make sense. If I perform some additions of the number, it will make sense, right? So addition, deletion, subtraction, average, all kind of numerical analysis of the data would make sense, and this can take a lot of different values, right? A lot of possible values. Sorry, lot of possible values happen here, right? Correct. Uh, that's what happens when you talk of numerical data, right? I'll come to the notes part of it. I'll show you the notes, and then you'll be having the notes on Moodle as always. Uh, yeah, okay. And so that's what new continuous data is, and you know a lot of different examples, right? So the price of a car would be a continuous value, right? Uh, similarly, height of an individual would be a continuous variable, right? So all of these are this is continuous variable, and then we have categorical variable. So um, categorical variable is a variable where the data can be numeric or any string or any other type. Generally, it is string data. It can be numeric as well, but you have only few possible values, right? Few possibilities, and you kind of divide the data into certain categories, right? Based on the few possibilities, whatever data you have, that can be divided into categories, right? So you have, say, data as male and female. That's my categorical data, right? Fine, everybody is good with it, right? Similarly, which country you belong to? Somebody belongs to India, somebody belongs to US. So again, I can group the data on the basis of the country that you belong to. Fine. Now, based on this, when you do the exploratory data analysis, when you try to explore the data, based on the type of data, the exploration would be different. The kind of analysis that you do would be different. Okay. All right. Now let's quickly understand this. Now, whenever you start with any kind of data analysis, the first and the foremost step that you do is EDA, or exploratory data analysis. Anybody who can tell me what EDA is? Yes. What is exploratory data analysis? Um, yes, Shruti, Tanmay, Shalini, Sandeep, Buddhi, Sandeep, and Sandeep. Could do anyone? Rohit, Nisha, anyone? Okay. See, whenever
So
you try to,
basically,
okay, go ahead.
so
Go ahead.
basically, it is reviewing the data. If we can review the data, like
Okay, reviewing your data. Okay, uh, to an extent you are right, but I would not say only reviewing. Basically, you want to summarize the data, right? It's all about summarizing the data. Okay, and how do you summarize the data? You want to understand, the high level overview. You want to have, when you say review, I'm just taking the same thing there. Um, High level overview of the data is what you're looking for, right? So you want to have just kind of, if you have, say, 100 different variables in your data set, you would want to explore each variable. So when you do exploratory data analysis, it can be of two type. It can be a univariate analysis where you try to explore each variable individually, or it will be a bivariate analysis where you're trying to find relationship between two variables. Okay, univariate and bivariate. We'll understand both of that. Okay, univariate would be primarily that you're trying to explore each individual variable, right? You're trying to understand, say, if it's a numeric data, then you explore it differently in terms of mean, median, mode, the frequencies, the distribution the data follows, the variability in the data, right? And if there is missing values, some kind of problems in the data, all of that you would want to see, right? Each individual variable. Bivariable, so there's a dependent variable and there's an independent variable. How are they related? What kind of relationship exists between those? That would form my bivariate analysis, right? So you'll have univariate analysis and bivariate analysis, and you'll be working with both of that. Fine, everyone? Yeah. So you'll be learning both of that. And exploratory data analysis deals with both kinds of analysis. Okay, both univariate as well as bivariate. Okay. Now, when you do exploratory data analysis, one is, okay, yeah. So Shalini, I think you logged in twice, and the moment you did that, there was a echo, so I just dismissed you from one of the sessions. Okay, coming back here. So when you talk about exploratory data analysis, I told you it's all about summarizing the data, getting high-level overview about data, and for this, we'll be using descriptive statistics. Okay, we'll be using a lot of descriptive statistics, and that is what we'll be learning in the first phase. And once we have done that in a week or so, we would move on to um, the inferential statistics part, right? To do this, you'll also do a lot of different data visualizations, right? Data visualization will also come into picture, and we'll create different kinds of charts, right? What could be those charts that we can create to understand single variable and two variables? We have talked about it. We can create a box plot. If you're exploring single variable, you can create a box plot. You can create a histogram, right? A histogram can be created. This is both when you are doing univariate analysis, okay? This both will be required when you're doing univariate analysis. Then you'll be using box plot and a histogram. When you're doing bivariate analysis, then you can have other kinds of plots like a scatter plot, or you can have a Q plot. We'll see both of that, right? And other charts also, right? A Q plot or QQ plot, as you call it. We can do that, and we'll see that, understand that, all of that in depth. Okay, all right. Uh, okay, but before you get started with any of these, um, how many of you have some understanding about statistics? Some understanding about statistics, any kind of understanding you have about stats? I've taken away the screen. I'm just opening up the notes for the time being. So if you have any understanding of statistics, I'm okay to take that up quickly. Whatever you know, you just quickly tell me. Yes. Okay, you're saying you saw understanding and then you're not letting me know any understanding of your. Okay, fair enough, no problems. Let me try
Sir,
and explain this. Okay, go
I
ahead.
know about descriptive, predictive, and prescriptive analytics.
Okay.
Descriptive statistics I know.
hmm what is it? Descriptive
So it
statistics.
is like it is a quantitatively measuring of data. So like it is like
Okay.
we are statistically measuring the data, like we have measure of central tendency. So in
hmm
this we have mean median mode, so we can
hmm
measure the data.
Okay.
And we have um, um,
Okay, fair enough, no problems.
and
Uh, that's all right.
variance also we can measure.
Variance also we can measure. Yeah.
Measure
So
of
there are multiple ways in which you can
standard
do that. Yeah.
deviation.
So yeah. So okay, we'll talk about that. We'll see that. Okay. Uh, okay. Let me just open up my notes and then we quickly get started. Okay. So okay. So let me first talk about descriptive and inferential. We're talking about that first, and then we'll go to the notes, right? Let's do that thing. Okay. There'll be a lot of problems that will be coming your way. So we'll come to that in a while. Uh, Yeah, that's all right, Nisha. You should not be missing anything. It's primarily a basic theory thing that I'm telling you. So you should be good about it, okay? Yeah, all right. Uh, okay. So we talked about descriptive statistics, and I told you descriptive statistics consists of um, basic high-level overview of data, and Shruti was recently telling me about. I mean, Shruti just told us about various measures of tendency. So there's a measure of central tendency, right? That is a topic in that. I will talk about that in depth. This measure of central tendency, which will consist of mean median mode. There is measure of variability of data, right? Where we'll talk about the standard deviation, the variance, and so many other things, right? Then there are different kinds of distributions that we'll talk about, right? The normal distribution, the Poisson distribution, the binomial distribution, the sampling distribution, right? So all those different kinds of distributions, what they are, how do they work, we'll understand that. We'll understand the concept of standardization to an extent. And apart from this, we'll also try and understand the concept of frequency distribution so that we are able to work with histograms. Okay, so frequency distribution is something that I'll talk about it before moving to measure of central tendency, right? So these are the things that we'll talk about in uh, in sampling, in descriptive stats. Then there is another topic called inferential stats. Anybody has any idea on what that is? I'm trying to keep it simple for now, not getting into the concepts for now, just trying to help you understand the overall structure, right? Okay, so inferential statistics, what does it do? It will help us understand about the population data, right? From the population data, it will help us understand about the population data, and that is based on the sample data, right? So based on my sample data, I would try and predict how the population would behave, right? That's what we want to do when you do predictive modeling. So you have some known data, correct? Which is generally you can take that as your sample, and based on this data you create a machine learning model, right? You
ചോദിക്കാൻ പറഞ്ഞു നിന്നോട് എങ്ങനെയാ അതിന്റെ ഓക്കെ ശരി. ഓ ഒരു പരിപാടിയില്ല എന്നാ വെച്ചാ മറ്റേ വെല്ലിച്ചന്റെ മോള് വന്നിട്ട് മറ്റേ കല്യാണമായിട്ട് മനസ്സിലായോ? അന്ന് നിന്റെ അച്ഛനമ്മ വന്നില്ലായിരുന്നു. ആ അപ്പൊ അവര് വന്നിട്ട്
okay, I don't know who that was. I could not see your voice. I think whosoever it is, if you're in the class, try and keep yourself muted if you're talking. It kind of breaks the momentum and everybody gets disturbed. Okay, so ensure that does not happen. I don't know who that was. Okay, so then that's all right. I'll talk about everything. Don't worry. We are just getting there. So okay. So we in machine learning, right? This is something that you would know, right? I generally talk about it in the demo session also. That whenever you work with machine learning, you're trying to work with known data, right? Based on the known data, you try and create machine learning models, okay? And this model that you work, right, that you create, you want it to work on the unknown data, right? Inferential statistics helps you do exactly that, right? You want to have a high prediction, high accuracy of prediction, even for the unknown data, right? Inferential statistics helps you do that. It'll help you judge the quality of the output that you've got. It'll help you understand the whether what you have kind of predicting for sample, does it hold true for population or not? That is something you would want to know. Okay, so that's what inferential statistics will do, right? Let's quickly understand sample and population. How many of you know sample and population? Anybody who can tell me what is a sample and what is a population?
Population is basically a whole for any data, and sample is just a small part
Uh, if you can give
of
me
that
a
whole
quick
population.
example, give me a quick
Ex
example.
Example like any, anything
Okay,
like if we have such anything
I'll come to
example.
inferential one more time. Okay, Shalini, just hold on. So, see, there are two things, right? Suppose I am interested in finding, let's take a very simple example, understand this, right? Suppose I am interested in finding the um, average height of people living in Mumbai. Okay, average height of men living in Mumbai or men living in Pune. Suppose that's what I want to do. Okay, since I was based in Pune, so I always take that example by default. Okay, so I'm looking for average height of men living in Pune. That's what I want to know, right? Now, this is the question, right? This is neither a sample nor a population. That's the question. I want to know what is the average height of men living in Pune. Now, in Pune, how many people would be living? Maybe about 10 lakh, 12 lakh men at least. Maybe a little more than that, but at least about 10, 12 lakh, right? Okay, that many male would be there in Pune. Now, do you think it is feasible for me to collect data for all 10, 12 lakh men and find the average of that? Will it be an easy task? No, right? It is not possible for me to collect data for the entire population. So when you talk about the problem at hand, right? The problem is I want to figure out what is the average height of men in Pune, right? In that case, all the people who fulfill this criteria, right? Everybody who fulfills this criteria would form my population. So all those 10 lakh, 12 lakh, whatever we said, the individuals that will form my population. My population will consist of all the people who are fulfilling this criteria. Correct. If I was interested in finding the average price of meal, say in Mumbai, right? Now all the restaurants in Mumbai or whatever eateries I have in Mumbai, that will form my population. Now, as I told you, it's not feasible for you to collect data for the entire data. I mean, for the entire population, right? So population is the whole, everything that fulfills the criteria in question. You would not want to take the entire data in question. So what you would do, you would take some part of it, right? You would randomly select some data and that would form your sample. Okay. For example, I'll give you another example, right? When elections happen, right? You had elections, the elections will happen. And after the elections, um, there is a um, there is an exit poll, right? Everybody understands exit poll. Anybody who does not understand exit poll, you understand exit poll? What happens in exit poll? Any news survey agency would do an exit poll and they will predict how many seats a given party is going to win, right? Yes or no? A party X will win certain number of seats, party Y is gonna win a certain number of seats, right? They give you a value. Yes or no, everyone? Now,
Yeah.
suppose in India the elections happened and
Yes,
there are
yes.
say 50 crore people who voted, right? Imagine that's a random number there, right? Now, it's not feasible to know which person voted for which particular party, right? Those 50 crore people. So what you do, you try and take, say, some random 50,000 people or 1 lakh people, okay, maybe a little more than that also. And based on that, you try and conduct a survey. Yes or no? And based on this survey, what would you do? You would try and ask a few questions, you'll understand the data. And based on this data, this is your sample, right? For now, this is your sample. People who have whom you have taken for your analysis, and this is my population, right? Everybody who fulfills the criteria here, correct? If I want to predict which party is going to win how many seats, I need to know the votes of all the individuals, right? So I need to know which person has voted for whom. So I need to know about the population. But since I cannot know about the population, I would take a sample. And based on the sample, I would try and predict for the population. From the sample data, I would try and predict what the population behavior would be like. Okay. I am trying to understand about the population behavior based on the sample data. Are you all able to understand this? That's what happens in inferential statistics. Inferential statistics helps us understand about the population data from the sample data. Okay, and there are two major concepts to it. One is estimation, and the second one is hypothesis testing. We'll talk about both of that in considerable amount of depth. Everyone with me till this point? Shalini, got the
Yes.
answer to your question?
Yes.
I have a question.
Yes, right? Okay,
Yeah.
all right. Let's move on then.
I have a
Okay,
question, Krishna.
go ahead.
So basically, inferential statistics would be applied on the sample to infer about the population, right? So we're going to
That's
be applying that only on the sample, right?
generally you do it on the sample because otherwise, I mean, you generally don't have data for the population. So 99.9% of the times you won't have the data for the population. For example, if you have the population data, you can directly get to know about the population, right? You don't have to infer anything about it because you have the data in place. So for example, if I have a classroom, I want to know the features only about that classroom. Then probably I have 50 students in that class. I can easily collect that data and I can know about it. But if that classroom, say I'm talking about class 10th, and I want to extend that analysis to the entire country, all the class 10 students in the country, then that acts as a sample. And maybe, I would not take just a random data. I mean, one particular group of students, maybe I'll have to do a lot more things. Sampling would come into picture there. And based on that, I would try and extend my analysis of those, 50, 100 or 500 people for the entire population. Make
Okay,
sense?
yeah, got it. Yeah, thank
Right?
you.
Okay. Yeah. All right.
Yeah.
Uh,
Tushar,
yeah, good.
uh, yeah, Tushar, there was a figure on top of this where you mentioned some ML models. Could you please take me to this figure? The
Yeah.
figure right on top of this.
Yeah, I get it.
Yeah. So what is this ML model?
Machine learning model. ML is a machine learning model that you create, right? When you do predictive modeling, uh, whenever
Okay.
you do, I think you were not in a demo session that I took. You will talk about when you talk about machine learning, uh, the output that you get after applying machine learning algorithms on data is a machine learning model, which basically represents the relationship between the input and the output variables. So suppose you want to predict a certain output variable, a dependent variable, and that is dependent on say 50 different variables. Um, what kind of relationship exists between the input and the output variable? That is defined in the form of some equation or some chart, and that is known as a machine learning model. So based on the known data, you try and create a ML model, right? Once you create that model, once the model is created, yeah, once the model is created, then you use that model to work on unknown data. Because for the known data, you already know things, right? For the unknown data, you would want to predict. Make sense?
Yeah.
Okay. All right. Uh, population and sample, we'll take more examples, right? So don't worry about it, Isha. So there'll be lots of examples coming your way. Uh, all right. Let's quickly get started. So okay, inferential statistics clear, and descriptive statistics clear, right? Both these are important concepts. I'm again going from the very basics, right? So these are the two branches of statistics that you really kind of need to know as a data scientist. And if you know both of that in good enough depth, a lot of your analysis would become, I mean, a lot of interpretation of data would be easier, right? Again, you don't have to worry about the formulas. It's more about the interpretation that you do with your data. Okay. All right. Okay. Let's move on. Why do I keep coming back to this? Okay. Uh, Fair enough. Let's take this example and we'll understand this example. Uh, Before this, let me talk about a simple concept of a survey. Okay, so there are various data collection methodologies. I told you, right? Whenever you do any analysis of data, the first step that you do is data collection, right? And there are multiple ways in which you can collect data. There can be a primary data collection methodology wherein you are saying that uh, whatever data you have, you are collecting it firsthand, right? You can do a survey. Survey is one such method where you are collecting the data firsthand. You're manually going out there and collecting the data, right? Or it can be an online survey as well, but you are involved in the data collection process. And there's another secondary way, which is what we do, say 99 or 100 times, wherein what happens is you have the data already in place. It's stored in some or the other databases, in some servers or somewhere, in some central repositories, in some website, or you just either you scrap the data from the web, or you kind of collect it through databases. So there can be ways in which the data, various places where the data can reside. You need to just collect the data from that place and you can have it in your system, right? Most of the times it's a secondary data collection that you do, right? You don't manually do that. But I'll just talk about survey quickly. So when you talk about a survey is a simple data collection methodology, right? What happens in a survey? Uh, what happens in a survey is a survey is the basics data collection methodology where uh, you would collect the data first, and as I said, so it's a simple data collection methodology. And the second important thing that you need to understand is um, you would collect the data for the sample or for the population. Can somebody tell me, when you do a survey will be done on a sample or on a population?
For the sample.
So for the sample.
Sample everyone, right? We would be doing the
Yeah.
data collection whenever you do survey would be done for the sample. And then using the data that you have got for the sample, you would try and infer about the population, right? The way we talked about the example of the exit polls, right? In exit polls, same thing happen. You have data for the sample, you collect data for the sample, and once you have the data for the sample, you try and understand about the population, right? You infer about the population from that data. Okay, all right. So we're good on that. Now let's take a simple question, and then you'll have more clarity about sample and population and all these concepts. Okay. Uh, Okay, suppose you have a very important exam tomorrow, right? And since you have an important exam tomorrow, you would obviously want your memory to be pretty sharp so that you can do well in your exam. And if you're doing well in your exam, uh, you know, you kind of achieve whatever you're trying to achieve there, right? So there was a survey which was done, and in this survey, a lot of people were asked that if you have an important exam tomorrow, right? And how would you prepare for the exam, right? What do you do one day prior to the exam to prepare for the exam, right? Consider it's a very important exam for you. So when that question was asked in that survey, 42% people said that uh, they would have a good workout, right? 28% said that they'll have a heavy dinner, good dinner. 16% said that they'll stay up and study all night. 13% said that they'll have a good night's sleep, and 1% people chose the other options. Okay. 42% said that they'll have a good workout, 28% have a good dinner, 16% said that they'll stay up, study all night, 13% have a good night's sleep, and 1% chose the other options. Okay. Now, my question to you is, um, if you want to decide, right now, the problem here is that this survey was to be done by you. Probably you are doing a research and you want to understand about the impacts of various activities that people have, and um, their results, right? So how do people perform in an exam with respect to what kind of activities they do one day prior to the exam? You're doing some research on that, for which you wanted to collect this data, and unfortunately you could not do that because you were not available, that day, and you asked a third party vendor to collect this data for you, right? A third party survey or agency, a survey organization, you asked that company that can you collect this data for me? They said, okay, we'll collect the data, and they gave you this results, right? That this is what we got. Now you need to present it in your white paper, right? You want to publish this, and you want to have more findings about it, right? So you want to be sure about this result. Okay, you want to be more sure about the findings that the or the analysis that the survey or the agency has given you. Now, which information out of these, right? Consider this to be A, B, and C. Which of these three information would help you decide or know whether the results is good enough or not, or whether I should trust the results, or whether I should, reject the results of the survey? Which of these information will help you do that? And think about it. Answer on the chat window. You have 30 seconds. Question is clear to everyone? Anybody unsure of the question? Yes, just about time, another 10 seconds. Okay, fair enough. Let's get going there. Uh, okay, so let me ask a few individuals what they've answered and why they've answered that, right? Let's take it that way so that we know um, what are your thoughts and why you are having certain thoughts. Okay. Okay, Praveen, you said B. Okay, anybody who said A? Okay, Shruti, you said, Shalini, you said A. Let's take your opinion. First, talk about A only. Why do you think option A is correct? Or why will that option help me?
Actually, I believe that it is very important to take the good number of people on the basis of which we can finalize that, okay, if the survey has been done on these many people, then we can conclude something. Like if it is an election, then definitely 10 or 5 people would not help it. So there has to be a big number of people. So it
Okay,
depends
so
upon how
you're
many
looking for a
people.
number, how many people I surveyed. If you get that number, that will help you understand or maybe have a better conclusion about the data. Why does it
Right.
always happen that if you have a larger number of people, it will be a better outcome? Now I'm going one level further deeper down. Okay, you're saying that if you have a larger number in your data, it will help you take a better decision, right? Now my question is straightforward. That's open to everyone. Why does it happen that if I take a larger number of people, I will get a better result? Why would that happen?
Because the more
Shall we?
we will going to take more people, it will be more closer to the population, and that will be better for us to get the accurate result.
Okay. Um, Basically, okay, let me try and explain. What you said is correct to an extent. I'll explain this. So when you are trying to talk about sample, so here we are working with the sample data, right? What you have is the sample data. Now you have some population, right? If you take a very small sample, the sample might not be representative. Uh, uh, Sample might not be representative of the population, right? And as you keep increasing the size of the sample, the chances is that the sample would start representing the population better. Do you agree? As I keep increasing the size of the sample, when I'm saying I'm adding more and more people, what am I trying to do? I'm trying to increase the size of my sample. Everyone, are you able to understand that? Right? This would be
Yes,
again my
yes.
sample, right? Isha,
Yes.
you understand this example between sample and population again this time? So this people that I'm surveying would be my sample, right? And obviously, a lot of people. What would be my population in this case, by the way? Who is going to tell me what would be my population in this case?
So the
All
population
the
will
people who
come
are
giving the exam tomorrow.
All the people who have an important exam the next day,
Not tomorrow,
right?
right?
That will form my
Right.
population because for all of them, this analysis would work, right? Or should work, correct? So everybody who's taking part, who is having an important exam tomorrow, is my population, but I'm taking only certain individuals on which the survey is being done. So that forms my sample. Is that clear now? One more example.
Yeah.
Yes. Okay. Now we are trying to say that if you keep increasing, when you say you are doing more and more people, which would mean that the sample size is increasing, and as the size of the sample increases, the representation of the sample in the population would be better. With better representation, the sample is closer to the population, and as the sample becomes closer to the population, whatever you are trying to understand, whatever you're trying to predict, that would become closer to the actual value. Okay, so how many people are surveyed would be important. Okay, uh, let's take another. Anybody who said B?
Yeah.
Nisha, you said B, I think. Anybody else who said B?
So I think all three parameters are required, and mostly the right audience is something which we need to look at. So who I surveyed is the one which we need to take care of, and as well
Okay,
as
when you
how
say,
it
okay,
looks
let's
like
talk.
all the,
Sorry,
yeah,
sorry to interrupt you there. When
yeah,
you
yeah,
talk about
got it.
your audience, can you just explain about who I surveyed will, I mean, why is that important, or what if I take some other data, and what kind of problem can happen there?
Yeah. So basically, if we are taking the survey, it needs to be the person who is going to the same means they should have the same scenario existed for them. Then only they will give the right answers.
Okay, so basically, same thing, right? When we said we are trying to survey people, even if I take 1 lakh individuals, and suppose I'm talking about talking to people who are not going to take an exam in another 10 days, or or not taken an exam in years together, whatever they say would be inconsequential to me, right? Because I'm trying to talk about people who are not even part of my population, right? So my sample should be part of my population. I should not be taking a random sample, a sample which is not part of the population, right? So it's very, very imperative. It's important that you take a sample which is part of the population always. Okay. So if you are trying to understand about weather patterns in Mumbai, you would not want to collect data for New York. Correct? It would not make sense. You would want to collect data for Mumbai only. Then only you'll be able to predict how it happens for Mumbai. Even if it's Mumbai, you cannot collect data for Pune also. Correct? Just because Pune is closer to Mumbai does not mean that you take the data for Pune, right? Correct? I'll talk about that, Ravi. Okay. Fair enough. So who I surveyed is important because you need to ensure that your sample is coming from the population. Again, I'm going to the very basics of statistics so that the foundation is laid, right? Once you have this clarity, any problem that you do uh, would be easier to do, right? Okay. All right. Okay. Then the third one, how the survey was conducted. Yes. Niharika, I think you were talking about that C option. Why do you say that?
Like according to me, I believe like what all conditions we checked during the survey, conducting the survey. So
Hmm.
it should be relational to this the survey which we are doing. So
How
actually,
the
like
okay.
three.
Okay, go ahead. I mean, first two, we are fine, right? We understood that. How the survey is conducted, we are focusing only on that. I could not get it. Can
No,
you just repeat what you said?
actually, like all the points are required during the when we are conducting the survey, and also
Uh-huh.
like we need to check the conditions when we are how the survey was conducted to get the like better result.
Okay. Okay. Fair enough. So I'll explain that. So what you said is correct. Ravi, you were trying to add something. Can you just quickly do that, and then we'll move on?
I was saying that whatever we have to take the selection, it should be into any category. It should not be biased. That if we are taking a sample, it has to be from one category.
One
That's what
category
I.
as in, okay, we would
In
not
category in
know
the sense.
what, we don't know what the other person is going to respond, right? So we cannot be, we will not be able to say that we are choosing a given category. Whatever comes, comes. Okay. Now, when you say how the survey was conducted, let me just talk about it. So how the survey was conducted again is important, because you would want to know what was the, because on the basis of this, you're trying to decide whether the survey was done properly or not, right? At the end of the day, this entire exercise is to know whether the survey was done properly or not, right? So if you want to know, okay, if you're told that this was an offline survey or an online survey, right? Or how the questions were framed for the survey, when the questions were framed, how were people responding to this? So many things, right? So you basically want to understand that there is no biasness which is introduced while conducting the survey, right? If there is some kind of biasness which is introduced while conducting the survey, probably it's not a good survey, and maybe you cannot rely on the results of that survey, right? So
Correct.
whenever you kind of do any kind of survey or any kind of analysis of data, you would not want to introduce any kind of bias, because if the bias comes in, the analysis is not impartial, and if that is impartial, not impartial, the chances that it would work well on an unknown data would be reducing, right? So that you don't want. Okay,
Correct.
therefore we don't allow overfitting also to happen in our machine learning modeling, right? When we come to machine learning, we'll talk about overfitting and we'll talk about that in depth. So overfitting actually is a biasness to the data, so that again we don't want. Okay, all right, I think we got the gist of sample population and everything, right? Let's move on. Let's quickly move on to another important area. um, why is it getting stuck? Okay. Okay. Okay, I'll just talk about this, although it's not very important, but just quickly touch upon this. Uh, okay, so basically, there is a concept of construct, and constructs are basically variables for which you do not have a standard unit of measurement, right? For which those variables for which you do not have a standard unit of measurement, standard unit of measurement does not exist. Does not exist. All those variables are known as constructs. Can you give me an example of a construct? Constructs are variables. I mean, just a bit of theory. Even if you don't remember it, that's all right. Because I'm using it in certain examples is why I'm explaining this here. So all those variables which do not have a standard unit of measurement are known as constructs. Okay. What do you think will be construct? Any example of a construct that you can give me? Any variable for which you do not have a standard unit of measurement?
Or gender, names.
That's categorical data.
So by standard unit, what exactly do you mean?
See, for example, when we say time, right? Time can be measured in a standard way across the globe in minutes, seconds, hours, right? So that everybody understands. Similarly, if you say 1 pound of sugar or 1 kg of sugar, you understand, everybody understand that pound is a standard unit of measurement of weight, right? So if you want to weigh something, you know that there's a standard unit of measurement and you can use that, correct? Now, think of a variable where you don't have a standard unit of measurement.
Uh, pain.
Sorry.
Sorry,
Sorry.
no problem.
IQ, I mean
Pain can
satisfaction
be the
or
one.
Satisfaction, pain, okay, any kind of feelings, right? Any kind of emotion that you talk about, you would not
Emptiness.
have a standard. Yeah, any kind of emotion that you talk about would not have a standard unit of measurement, everyone, correct? So if you're trying to
yes.
measure that, if you're trying to measure, um, say how happy I am today, now there's no standard unit of measurement for that, right? Correct. But if you really want to measure it, you can come up with a way to measure it. Suppose there are 5 friends, right? And how about memory? Memory, can you measure? Is there a standard unit of measurement of memory?
No.
No.
No, right?
No.
Again, we don't have a standard unit of measurement of memory, right? So if you want to measure memory of say 5 individuals, say 5 of your friends are you know there, and you think that some kind of challenge comes up and you say, okay, let's see whose memory is best, then how do you go about doing that?
I do survey.
No, there are just 5 of your friends, right?
So we can make them
Five
remember
of
some things in
Okay,
certain time,
a lot of
and then we
background
can.
noise, not sure, Rishi.
Sir, we
So
check their expression.
Sorry, from somebody's side there's a lot of background, so if there's that case, just ensure that you're muted. Okay, somebody else was trying to answer that. Go ahead.
By using some memory
Yeah,
games, in placing
maybe,
memory games.
yeah.
Memory games, right? One could be a memory game. So I can say, okay, let's try and see how do you do that. So some memory game you can come up with, and you can say, okay, let's see who performs well in this memory game, and then we'll say this person has a better memory. Correct? Can be one way of doing it. Or as I think Rishikesh was saying, that you can ask them to remember something of some event that you were part of, all of you were part of, and then say, okay, let's see who remembers how much. Can be a
Sir,
way
by
of to
their
do that.
body language.
You cannot do that. I mean, you cannot measure somebody's memory by their body language. I don't think that's a correct way of measurement, because again, for body language you don't have a standard unit of measurement. At least you need to quantify thing, right? Because we don't have a standard method of quantifying it. That's why we are trying to figure out a way with which we'll try and quantify stuff, right? Whether it is memory game or a event that you remember, you try and see if you can quantify stuff, and based on the quantification that you do, you'll say, okay, this is good and that is not good, whatever, right? Or this person has done better than the others. Okay, so a lot of such variables, and why I'm talking about this, because many a times when you work with business problems, not always, right? Very at times you might end up with a business problem where you don't know how to get started, right? And in that case, uh, if you don't have a if you're trying to measure a variable which is a construct, you need to first figure out a way to measure that variable before you come up with a solution, right? So always try and ensure that whatever variable you are measuring, it is not a construct, and it has a standard unit of measurement. It is some in some or the other way you have defined, or you have come up with a way to measure that variable, right? Once you have that, then you can do that. Okay, let's take a quick example here. Out of these, which of these are constructs? Quickly on the chat window only, take it as A, B, C, D, E, and tell me which of these are constructs on the chat window. Yes, done. Okay, so gallon of gasoline, gallon is a standard unit of measurement, so obviously that's not true. Intelligence, IQ is not a standard unit of measurement. Okay, those who think IQ is a standard unit of measurement, that's incorrect. Okay, so that's incorrect. So you don't have a standard unit of measurement. IQ is, or intelligence is also a construct. Effort is a construct. Effort can be, it's not always in terms of hours, right? It can be manual effort, it can be physical effort, it can be mental effort. There can be different kinds of effort. You don't have a standard unit of measurement for that, right? Age, you know how to measure age, right? Age is measurable in,
Yeah,
age is
numbers.
measurable, right? In numbers, in years, in months, right? So there's a standard unit. Hunger, again, is a construct. Annual salary in US dollars is measurable. Sorry, this is measurable. Itchiness, again, is a construct, right? So B, C, E, and G, these are constructs. Okay, all right. Let's kind of move on quickly. Okay, I'm focusing only on the important topics. I'm not talking about something which is less important. Okay. Should I take this example? Let's take this example because we would need to. Okay, so we wanted to understand the relationship between sleep and memory, right? We wanted to understand relationship between sleep and memory. Okay. Now sleep is a measurable or a non-measurable quantity.
Non-measurable.
Mm,
Measurable.
Measurable, no? You can
Non-measurable.
measure
Okay.
measurable.
number of hours,
Number of
but
hours, number of minutes, number of seconds. You can sleep. You can decide, okay, how many hours you sleep, right? Quantity of sleep at least is measurable. Quality of sleep is non-measurable, but quantity of sleep is measurable. Correct? I want to
Yes,
understand
sir.
how the quantity of sleep is related to memory. How does it impact memory? Okay, that's what I want to know. All right. Okay. Then, okay. Now, we want to understand memory, right? How do you measure memory? Do you have a standard unit of measurement of memory?
No.
No.
No, right? Again, we don't have a standard unit of measurement of memory. So if you don't have a standard unit of measurement of memory, you'll have to come up with a way of
No, sir.
measuring it, right?
No, sir. We will decide by their grasping power, by their memory.
Okay, how do you decide that? What is the standard unit of measurement there?
No, sir. While by their grasping power, how much they grasp in 1 minute
No,
or in 1 hour.
I mean, how would you calculate that, Sanket?
No, sir. If suppose you explaining something and some people understand very fast and some people not understand
I understand.
that.
No, I understand. No, I'm not saying that. I'm saying, how do I measure that? I have to take a test, right? There's no standard
Uh,
unit of saying that how much you grasped, correct? Do you have a standard
I
unit of measurement? You don't have it, right? So that's what we are talking about. So we don't have a standard unit of measurement of memory. Therefore, we have to come up with our own way of defining or measuring memory. Okay. All right. So yeah, so we'll come up with a way of measurement of memory. And what we did was we said, let's try and take something called a face memory test. Okay. We gave students something called a face memory test. And what we did in this face memory test is, um, to every individual who was taking this test, that person was shown a set of 12 photographs, right? A set of 12 photographs was shown in part one. He was given a 5-minute break. After another 5 minutes, after 5 minutes were passed, another set of 12 photographs was shown. Okay, another 5 minutes passed. Okay, and once these 5 minutes had passed, then the person was asked another set of, so he was shown a set of 48 photographs. Now, for each of this 48 photograph, there were two questions asked. One was, this is our own way of measurement, right? This is not a standard way. So in our case, we said, okay, let's try and decide it in this way, right? So this person was asked, have you seen this photo before? Have you seen this before, right? I'm just writing it, scribbling that around. Second is, if the answer to this question was yes, right? Then the second question was, in which part did you see it? In which part did you see it? Part A or part B? So if you have seen a photograph, see the photographs in part A, look at the photographs in part B, and then in part C, we will ask you which of the photographs you have seen before, right? In part A or part B, and in which part did you really see that, right? So you need to remember where was the photo seen as well. Okay, and once that is in place, you would be able to understand how well, or how well somebody is done. So the percentage of correct answers given to this question, right? Have you seen this photo before? Was termed as memory score, or not really memory score. It was termed as recognition score. Percentage of correct answers to question one, have you seen this photo before, was termed as recognition score. Okay, and percentage of correct answers to question two was termed as memory score. Okay, that was termed as memory score. Now, or temporal memory score. So this was calculated for individuals who took the test. Okay, now we took 3 individuals, right? We asked them, how many hours did you sleep in a given day, right? And just one day prior to taking the test, right? So suppose you're taking the test tomorrow morning, how many hours did you sleep today, right? So somebody said slept 7 hours, 6.5 hours, 5.5 hours. And for those individuals, recognition score and temporal memory score were calculated and recorded. Okay. Now we are interested in finding what? We are trying to understand whether there exists a relationship between sleep and memory. Okay, we are trying to understand whether there exists a relationship between sleep and memory, right? And to be able to do that, we need to figure out whether sleep is related to recognition score and sleep is related to temporal memory score, right? We're trying to understand if there exists a relationship between these two. Now, based on this data, what do you think? Where do you think there exists a relationship? Where do you think that there does not seem to be in a a relationship here?
So as number of hours
Third,
slept is increasing, temporal score is also increasing.
Okay, so as the number of hours slept is moving up, there seems to be a increase in the temporal score. What about the other one?
No relationship in hours to recognition score.
Yes, so as you see, the number of hours slept is moving up. There does not seem to be a clear relationship. Although we have taken very few data points, that's not enough to kind of take a decision. But if you need to take a decision just based on this thing, um, then we will not be able to take a decision in this case, right? Fine. We'll have to say that based on this data, we cannot have that there is a relationship, right? Now, whenever you're trying to find relationship, what kind of variables are these? What kind of variable is hours slept, categorical or continuous?
continuous.
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 And what about recognition score and temporal score?
Categorical.
Continuous.
Continuous.
These are all continuous
Yeah.
Continuous.
variables, right? Everyone. So this is recognition score is also continuous, temporal score is continuous, and hours slept is also continuous variable, right? Okay. And when you're talking about these continuous variables, relationship, when you're trying to find relationship between two continuous variables, that is known as correlation. Okay, that is known as correlation. Correlation is basically relationship between two continuous variables. Okay, and you'll say that these two variables are correlated if there exists some kind of correlation or some kind of relationship between the two variables, right? So in this case, we'll say hours slept and temporal memory score seem to be correlated based on the data that we have, and these two do not seem to be correlated. Fine, everyone.
Yeah.
Based on the data, we'll say that these two seem to be correlated. The other one does not seem to be correlated. Okay, then moving on. Now, what is the conclusion that you quickly draw here, and then we'll move to the next topic. Yeah, what is the conclusion based on the previous thing? What would you draw? Yes,
The
option B,
second
everyone.
one. Yeah.
Correct,
Yeah.
More
everyone.
you sleep,
Option B.
better you are.
So you're saying the more you're sleeping, the better is your temporal memory score, right? So as the number of hours slept is increasing, the temporal memory score seems to go up. All right. So we are good about that. Let's quickly move on. Okay. Now there's another important concept here that I would want to talk about, right? Now,
Uh, I had a question here.
go ahead.
Yeah, in terms of sleep and memory, I'm just saying. So, if you want to relate sleep and memory in a better way, should it not be like same person sleeping less hours and when you check the same two parameters, and the same person sleeping more hours, and then you decide whether sleep is actually related
It's
to
true.
memory.
So, okay, what you're saying is true. We'll talk about it, towards the end. I take your point. So what he's saying is that when you talk about 10 different individuals, their sleeping patterns could be different. So how are we relating those with memory, right? That's the thing.
For example, I sleep
No,
4 hours
I mean, what
yesterday.
I said
I
was,
slept for
suppose you
4
have
hours
10 individuals who have different sleeping habits. And if I'm saying somebody is pretty fresh after 6 hours, somebody is not fresh even after 8 hours. So it will be difficult for me to decide the memory thing based on the number, just the number of hours of sleep. Is
Yeah.
that what you're saying? Correct? Yeah.
Think-
So I said we'll talk
Yeah,
about
kind
it
of.
towards the end. Yeah, we'll talk about it towards the end. Okay. I mean, I have a question framed for that, so let's discuss it there. Uh, all right. Coming back here. Okay, let's try and understand this. Suppose you have a car, right? Let's say you have a car, and the car is, say, currently 5 years old. Okay, and the okay, let's put it this way. let me take age of the car, uh, age of car, and say let's take mileage of car. Okay, I'm interested in figuring out a relationship between age and mileage. Okay, what is in general what happens? What will happen in general, age and mileage?
When car
Mileage
is new, then
mileage
when car
decreases,
is
right?
new,
It'll be inversely
Mileage
proportional, right?
decreases
As the
along with that.
age of the car increases, the mileage should come down, right? That's what we expect,
yes, sir.
everyone.
Yes, sir.
So it should be inversely proportional. Okay. Now suppose age of the car is 5 years and mileage of the car is uh, say 18 kilometer per liter. Okay. Now age of the car is 7 years, right? And the mileage has come down to 15 kilometers per liter. And I want to know, now this is my current state, imagine. I want to talk about future and I want to know what will be the mileage of the car when the age of the car is 9 years. That's what I want to know, right? Or maybe mileage of the car when the car is say 10 years old. What is the mileage of the car? I want to predict a value, right? Tell me, can I have a definite value for this? Okay, think
No.
about it and answer on the chat window. Can I have a definite value for mileage of the car when the age of the car is
No,
10 years? If I can have a
no,
definite
sir.
value, what is that definite value that I can have?
No,
If
sir.
I can have a definite,
We
hold on.
we
Let everybody answer. Let everybody answer on the chat window. I've asked you to answer on the chat window. Uh, Maybe what you're thinking can be wrong also, right? So it's not always correct. Okay, so let's try and see. It can be, if you think that there is a possibility I can have a definite value, well and good. You can go ahead and give me that number. Uh, and if you feel that's not possible, you can just say, okay, it's not possible, and give me a reason for that also, why you think it's not feasible to have a definite value of the mileage of the car at certain whatever year after 10 years. Okay, enough time given. Um, yeah, so I've got a lot of answers. So most of you are saying that it's not feasible, right? I cannot get a definite value of the car. Uh, Primarily because the mileage of the car is not just dependent on the age of the car, it is dependent on multiple other factors, right? So if I'm talking about mileage of the car is dependent on multiple variables, right? Age of the car is just one variable, right? What kind of road is it driving on, right? So road conditions, traffic conditions, right? Who is driving it? How many kilometers the car has been driven? How regularly has it been maintained, right? The maintenance of the car and so on and so forth. You can keep adding lots and lots of variables, right? So now, but I was interested in what? I was interested in a relationship between age and mileage only, right? Yes or no? Correct. I was interested in the relationship between age and mileage, but there are so many other factors which are also coming into play, which are not letting me find a definite relationship between age and mileage. So all these variables other than age, which are impacting the relationship or which are not letting me understand the relationship between age and mileage, all these are known as lurking variables. What are they known as? They are known as lurking variables, right? So lurking variables are variables which, other than the dependent and the independent variable for which the relationship is being figured out, all the other variables which are impacting my dependent variable, um, other than the independent variable that we are working with, all the other independent variable will be my lurking variables. Okay. So what would you want? Would you want lurking variables in your data, or would you not want it?
No, we don't want it. It
Right.
has to be
But
get minimized.
okay. So in this case, suppose this was the problem. How would you get that?
We can reduce this lurking variable up to certain extent, but we cannot say that like everything can be reduced at up to a certain threshold.
Okay, so whenever you're trying to work with data, I mean, if you're trying to find relationship between two variables, a dependent and independent variable, then uh, in that case, you cannot, I mean, you would want to either you want to remove, you would say that I remove the lurking variable if possible. If it's not feasible to remove the lurking variable, you would want to ensure that its impact is minimal, right? Or it becomes constant.
Correct.
Yes or no? So you would want to ensure that the variable is constant so that the impact does not happen and you are able to find a definite relationship between the variables that you are interested in. Okay, let's try and understand that. Okay, in this case, what else could be my lurking variable? What else, what other variable could have influenced our memory in the same the example that we were talking about? Yes, quickly, 30 seconds.
Maybe stress level and not paying attention.
Okay, time of the day you took the test, will it impact?
Yes.
Right, it might. It will impact, right?
Yes.
Why?
Yes.
Yes, quickly,
Depends
somebody
like
was trying to
when the
answer that.
yeah, it depends when the tests were taken. Like in the morning, when everybody was fresh, or in the evening, or in the afternoon, or like on the weekdays, on the weekend. Like
Okay,
depends at
so
what day of the
basically at
time.
the time, yeah, so not everybody works, you know, so if you're somebody who's working in a, at a certain time and you're not fresh at that time, it might, so somebody who takes a test, say thrice a day, suppose you yourself have to take a test either in the morning or in the afternoon and the night, your performance levels would change, right? So time of the day you took the test will impact uh, your score, your stress levels will impact your score, 5-minute breaks will
Minute
impact your
break.
score, correct?
Correct.
Okay, then what do you, so when I'm talking about 5-minute breaks, I talked about, right? So um, there are 5-minute breaks given after each part, right? 12 photos, then 5-minute break, another part, another 5-minute break, right? So that case, right? Your age again will impact whether you pay attention or not. That will also impact, correct?
Correct.
Yeah. So uh, yeah. So when you're working with this, time of the day, your stress level, all of these will be my lurking variables, right? Now, suppose I say that everybody is comfortable taking the test at a certain time, say 10 a.m. in the morning, right? Everybody says that I am doing only a general shift and pretty comfortable taking the test at 10 a.m. in the morning. And we say that, okay, let's see that everybody is taking the test at 10 a.m. in the morning. Now, your your confidence about relationship between sleep and memory when everybody is taking the test at a certain time or when people are taking the test at random, in which case do you think you'll have more surety about relationship between sleep and memory?
At the same time.
At the same time, anybody else, any other thought? Yes, quickly. Why at the same time?
Um, because again, the impact is now minimal of the lurking variable.
So now time of the day you took the test, that particular variable is a lurking variable, right? And when you say that everybody is taking the test at the same time, we are trying to control that lurking variable. We have controlled one of the lurking variables. Yes. Similarly, if everybody is if I'm saying that everybody age, people who are taking the test, their age group is between 25 and 28, right? Maybe in that age group, you kind of work in a specific manner. And again, everybody is paying attention. As we keep doing that, we keep reducing the lurking variables in picture. And as we keep reducing the lurking variables, what will happen? We can be more and more sure about the results that we have, right? Everyone with me on that?
Yeah.
Yeah, correct.
So you're
Okay.
basically making all the variables constant.
Yeah, so you're trying to ensure that you are making the variables constant so that the lurking variables move out of the picture. And when lurking variables move out of the picture, you can be more sure about the results. Okay. All right, good. All right, let's quickly move on. Okay. Uh, this is an important question. Now, again, a quick question there for everyone. So, there's a concept of population, there's a concept of sample, right? And I'm saying uh, for the population, the average recognition score value is 92%, right? The average score for the population, average recognition score for the population is 92%, and average temporal memory score for the population is 68%. Okay, that's what we know, right? Average recognition score for the population is 92%. Average recognition score for the, sorry, average temporal memory score for the population is 68%. Um, what do you think my population would consist of in this case? What would comprise my population? You have a say 20 seconds to think about it and then answer on the chat window. What will comprise of my population in this case? Yes, what would my population comprise of? Yes, what will my population consist of? Anybody can answer now. I'm talking about this face memory test, right? I'm saying in the for the face memory test, the average recognition score is 92% and average temporal score is 68%. Now I want to know this average recognition score or average temporal score is for what? For the population, right?
Yeah.
Yes, this is for the population, right, everyone? If this is for the
Yes.
population, what would it mean? That all the people who would have taken the face memory test till date, this score is for those people, right?
Yeah.
Correct.
Yeah, yeah.
Similarly, when you say average temporal score, the average in this case, the population would consist of all the people who have taken the test till date. Correct. It is for all the people who have taken the test till date, right? That's what we have.
Yes.
Okay. All right. And okay, now if I take a random sample, if I take say 5 of my friends and ask them to, uh, suppose you have taken 20 of your friends, some random friends, and ask them to take the test. Do you think their their average recognition score and average temporal score would be same as the population data?
No,
No. Why?
because you're taking a certain sample, just small number of people, not the entire population. So there's a high chances that will not be same.
There's high chances that will not be. Okay, go ahead. Somebody else is also trying to say something.
It depends on the number of samples that
Okay, generally what will happen is whenever you work with any data, okay, when you work with any data, your sample data and the population data, right? So you'll have sample mean. Suppose you take a sample mean represented by X bar, you have population mean that is represented by mu. Mu is the representation for sample mean, X bar is the representation for, sorry, mu is the representation for population mean, X bar is the representation for sample mean. Okay. Now, when you are working with this, right? Very rarely would it happen that X bar is equals to mu. That's your ideal scenario, right? Ideal scenario is you expect your X bar to be equal to mu, right? Your sample represents the population exactly. And if it does, whatever you predict for sample would work for the population pretty well, right? That's what would happen. That's your ideal scenario. But will that ever happen? Very rarely will it happen because the sample size is significantly different from the population size. So for the sample to be an exact replication of your population would happen very rarely, right? Now, if that is the case, then what would you do? There'll be a difference between X bar and mu. Would you agree? There'll be some difference between X bar and mu. It can be mu is greater or X bar can be greater, right? There'll be difference between this, and that is known as my sampling error. What is this known as? X bar minus mu, which is the mean difference between sample means. That's known as sampling error. Okay, and why do we call this as sampling error?
Because there is an error between the mean average or sample average and a population average. There's
Yeah,
a
so because we
difference.
have not been, because we have not been able to take a sample which is the exact replication of the population, and since we have not been able to do that, therefore we say that our sample is not a best representation of the population data. Okay, and therefore there's a difference in the sample mean and the population mean, and hence there's something called sampling error. Clear?
So our aim while working would be to have minimal sampling error when we perform analysis.
Yeah, I mean, you would not, yeah. So the way you choose a sample, when you choose a sample from the population, you'd want to choose a sample rather, which is as close a representation to the population as possible. If you have that, if you can do that, then it does help. But when you work with real-time data, it becomes very difficult. So whatever you get, you kind of work with that and you try and ensure that you kind of predict using that. But in the ideal scenario, that is what you would want. Fine. Make sense?
Yeah.
Yes.
Okay. All right, let's quickly move on. So this is fine. We know sample and population are different. Okay. Now, if my sample and population are different, and another important thing, I'll just quickly tell you this. When you talk about sample, right? We are saying we're just choosing a sample, and we are saying that sample is a representation of the population, right? And there'll be some or the other sampling error. So if you want to reduce sampling error, what do you do? If you want to reduce the sampling error, how do you reduce the sampling error?
And increase the
Sorry?
size of the sample I mean,
Okay.
make it
One
as
is okay, increase the size of the sample. That's a good answer. What else? The other important thing that you can do is you can always choose a sample randomly. Okay. You always choose a random sample. Now, why would a random sample be a better sample?
Be unbiased.
Because it is an unbiased sample. The probability of choosing this value or this value or this value or this value is same. So when you pick a data from the sample, uh, I mean, pick a data from the population to comprise a sample, each value has equal probability of getting selected, and if that is the case, the sample that sample has the best chance of being the representative of the population, right? So we always try and ensure that our sample is as as random as possible. Okay, so if you kind of do that, you would be in good shape. Okay, so always try and choose a sample which is random, and the other thing is that you always try and increase the size of the sample. If that happens, the chances that sampling error would be reduced is pretty high. Now, why does a random sample, as I told you, as one thing I told you is the probability of getting each value is same, right? Let me explain that to you through another example. Uh, okay, suppose it is raining outside your house. Okay, it's raining outside your house. Now, do you know at a given instant, at a given nanosecond maybe, where exactly a raindrop will fall? We don't know, right?
No.
Correct? We don't know exactly where the raindrop will fall. So if you want to know where exactly the raindrop will fall, I mean, it's not feasible for us to do that, right? But if you want to kind of understand that, what we can do is we can take, say, two, say, empty buckets. You place that 5 meter apart from each other, and you wait for, say, 20 minutes. You would see that after 20 minutes, both the buckets would be almost equally filled. Will that happen?
yes, most
Yes.
likely.
Yes, it is pretty
Yeah.
likely that both the buckets would be equally filled, right? Why will that happen?
Because rain drops are falling, I mean, equally
Yeah, so there's a
on all
random
areas.
distribution, right? Yeah, so the raindrops are randomly distributed in the population, right, across the land area. Similarly, when you talk about sample, the data points in the population are also randomly distributed. That happens for 99% of the cases, or 95% of the cases at least. So if you randomly pick data, your chances of being able to create a sample which is pretty similar to the population data would be pretty very, very high. Okay. So yeah, so that's something you should understand. So whenever you're working with that, uh, yeah, whenever you're working with a population, most of the time the data is randomly distributed in the population. So if you pick the data randomly, you have a pretty high chance of being able to have a sample which is a good representation of the population. Look at these two data and tell me whether there exists a relationship between the two.
No,
No.
Is everyone quickly?
At some
No.
point of time, like it seems like it is a relationship, but we cannot say like exactly whether it is a relationship or not.
Okay. Okay, let's try and understand this. Now, if you look at this, what is this, by the way?
Scatter plot.
scatter plot.
This is a scatter plot, right? On the x-axis, you have a continuous variable. On the y-axis, again, you have a continuous variable. Whenever you have two continuous variables, whenever you try and plot it, you end up with a scatter plot. Okay. Um, Now, based on this scatter plot, what do you interpret now?
Positive correlation.
Seems there's a proportional to, yeah,
There seems to be
positive
a
correlation.
positive correlation. Yes or no? There seems to be a, yeah. Somebody has a question there. Somebody has a question there? No, we're good. Okay. Yeah, so if you look at this data, when we look at the same data, right, here we were not able to understand any relationship. Seemed like there does not seem to be a relationship with this data. But if you look at this data now, there seems to be a trend in this data, right? If you look at this data, when we plot this data, there seems to be a trend, right? And the trend seems to be moving up, right? As the number of hours slept is increasing, the temporal memory score seems to move up, right?
Correct.
Yes.
Correct? Yep. Okay. Uh, yeah, so we see that as the number of hours slept is increasing, the temporal memory score seems to move up, right? But if I ask you another question, that if somebody sleeps more, right? If I'm sleeping more number of hours, is it compulsorily true that my memory will be better? If somebody is sleeping more number of hours, is it compulsorily true that you'll have a better memory?
No.
No.
Think about it and answer. Don't rush to an answer. Think about it and answer.
You know.
Sure, everyone. Okay, there's high probability of it's not compulsory. Why is it not compulsory?
There could be other lurking variables that we have not taken into consideration here.
Okay, there can be lurking variables that we have not taken into consideration. That's one thought to it. What else? See, if you look at this, I mean, that what you said is an explanation to, if you look at this data, right? If you just look at this, there are two individuals, right? One has slept 5 hours, the other person has slept 6 hours. If that statement is true, that if somebody sleeps more number of hours, his memory is definitely better, then you could never have data like this, right? Or you cannot have data like this, that person sleeping same number of hours but having different scores, right? That's happening across this place, and this place, three. If you look at this instance, again, there's one such instance, right, which is happening. If you look at these two numbers, again, there's an instance there, right? So a lot of such instances are there where we see that people having either same number of hours are having different scores, or people having different number of sleeping different number of hours are having same scores, which would never happen if it is definitely true that if you sleep more, your memory will definitely be better, right? If you sleep more, if the memory is definitely better, then this situation should never arrive, right? Okay, and why is that happening? As clearly pointed out, as very correctly pointed out, that this is because uh, because because of
Lurking
other lurking
variables.
variables, right? There are other variables which we have not taken into consideration, which are impacting the relationship between sleep and memory. Okay, all right, okay, fair enough. I think we are nearing the end of this important thing, important relationship. Yes, we're good about it. Okay, uh, all right. Now let's just quickly take this, and then we'll move to a new topic. Okay, there's another thing. uh, there's another concept, rather. I would just quickly talk about that. One is called uh, correlation, that we discussed right some time back, and the other is called causation. You need to understand that these two are different things. Correlation does not mean or does not imply causation. What does it mean? Correlation does not imply causation.
For
It means,
example,
go ahead.
uh, so like we just talked about sleep and number of hours. So there might be a positive correlation between sleeping and the memory, but
Mhm.
we cannot say that sleeping, like good memory, the cause of that is sleep.
Sleep, right? Correct. So if you see here, we saw that there was a positive correlation, which means as the number of hours slept was increasing, the temporal memory score was moving up, right? So there was a positive trend, but we cannot conclude just by looking at the trend that that the reason for sleep or the memory to increase is sleep. We cannot conclude that. We might find correlation between variables, but correlation does not imply causation. Okay, let's take a quick example on that. So there's this famous writer named Thomas Friedman. I'm sure if you've read of some of his books. One of the very famous books of this writer is The World is Flat. If you find time, you can always read that book. So in that book, he tells about this golden arcs theory, and he said that no two countries, have gone to war with each other post the opening of McDonald's. So op once the McDonald's is opened in the country, then those countries did not go to war with other countries having McDonald's, right? So again, there's a correlation, right? Opening of McDonald's and countries not going to war. So we see that there's a trend that whenever the McDonald's has opened, those countries don't go to war with each other. So there's a trend that we establish here. But the trend that we see is that because, are the countries not going to war because of the opening of McDonald's, or there's some other reason to it?
The reason.
Out of these four, which one do you think could be a possible option? Okay. Countries with
Globalization
McDonald's
and
are open to globalization, right? And FDI, so they would want FDI and FII, and those countries who are open, who'd want more money being invested, they don't want to go to war because in such cases, the investors would move out of the country, right? So you would not want to be in such a situation, right? All right. So whenever you are uh, whenever you are looking at two relationships, one is correlation and causation. Correlation can be there, but correlation does not imply causation. Okay, these are two different concepts and we should not mix them. Okay, survey we already talked about. There's a concept of controlled experiment. Let me just quickly touch upon that. uh, okay, at a high level. So one thing is correlation, right? But if I have correlation, if I see that there is correlation between data, and if I want to draw causation, if I want to draw a causal relationship means everybody is with me, right? Nobody is feeling left behind. Anybody who's feeling left behind?
No.
No, right? Everybody is good. Okay. So we are saying there is correlation between the in data points, and if we want to draw causal relationship between variables, we don't want to just talk about correlation. We want to draw a causal relationship. So if you want to draw a causal relationship, the to be able to draw a causal relationship the way we were doing age and say mileage, right? Now, if I want to have a definite relationship between these two, which is what a causal relationship would be, I need to ensure that I am doing a controlled experiment. Okay, and what does a controlled experiment basically mean? It means that the experiment or the test or analysis is done in a controlled environment. And why would you want to do it in a controlled environment?
Act of
Reduce the effect of lurking
lurking
variables.
So that you can control the lurking variables, right? Good. So if you're able to control the lurking variables, we're doing in controlled environment, so we'll be able to control the lurking variables. And once the lurking variables are controlled, we can have a definite relationship between the variables that are in picture. Okay, let's take a quick example and then we'll move on to the next topic. Okay, maybe 5-7 minutes. I'll take a quick example and then we'll move on to the next topic. Probably we'll need to take a break as well. Okay, all right. So let's take this a pharma company, right? A pharma company, a drug manufacturing company, right? Now this pharma company or drug manufacturing company, suppose has come up with a new drug. Okay, new drug, and consider that this is a sleeping pill. Okay, now they say that this pill is pretty effective. This is a pretty good pill, and this enhances the quality of sleep of individuals. Okay, but before the drug can be launched in the market, they need to get the approval from somewhere. Which organization approves that? Anybody else?
FDA.
FDA, right? So then they need to take the approval from FDA, and they need to get it into a place saying that, okay, FDA says that we are good to go, and um, the drug can be launched in the market, right? So they need to prove to FDA before the FDA can approve it that yeah, before they prove to FDA, they need to prove to FDA that this drug that they have is actually effective, right? So if you want to prove the effectiveness of drug, then you need to draw a causal relationship that it is the drug which is causing the person to sleep, and there's no other reason for that to happen. Yes or no? That's
Yes.
what you would want, correct? You'd want to prove that it's the drug which is causing the person to sleep, and there's no other reason to that, right? Now, if we want to get to that stage, we'll have to do a controlled experiment, right? Okay. So what this organization did, I'll just take a quick example. They got two sets of individuals, right? To one group, they gave an active pill, the pill which contained the drug, and to another group they gave the inactive pill or the placebo. Okay. Why would I do that? Why would I use an active or inactive pill?
The individuals don't know that they actually took the proper pill or not.
Yeah, so you would basically want to compare these two groups, right? You want to showcase that, okay, people who don't take the drug and people who take the drug, how significantly different the sleeping patterns is, right? Compare the drug,
Cover the
compare the
lurking
group.
variable.
Sorry, it's not about lurking variable. Sorry. Okay, you're able to understand. In one case, we're saying we have got a set of individuals who have taken the active pill, who have got the drug, and to another set of people who have not taken the drug, right? Who have basically taken a placebo. Placebo is a look-alike, is an actually a look-alike to a drug. It does not contain the medicinal content, right? It does not contain the active particles. Okay, but if I really wanted to compare, why would I take a placebo? Why can't I just say that, okay, take one people take the active pill, other people don't take a pill, and then compare them? I can do that as well, right?
Yes, but like then they will know that you haven't given any pill to them. But in this case, they will think that it's a sleeping pill.
To control the psychological impact of having the pill.
Sorry, come again.
To control the psychological impact of having the pill.
Um, so how would psychology play a part here?
Generally, doctors do that. Sometimes people think that if they take some pill, then they'll be fine.
Okay, so generally what happens when you talk about the drug, the pharma as a domain, psychology does play a part. If you are given a drug and you feel that since you have taken the drug, now you should feel better, you start feeling better, right? So psychology also plays a significant part. Therefore, to avoid that problem of psychology, everybody is given the pill, so everybody feels the same way. And again, the psychology is a lurking variable in this case, right? We are trying to control the lurking variable, which is psychology in this case, right?
Yes.
Yes, yes.
Okay. All right. Uh, okay. Good about it. Let's quickly move. So again, sorry. Yeah. So active pill and inactive pill they give, and they figured out. They tried to understand whether there's a problem, right? And they compared the values, and they said, okay, they will try and prove whether the pill is effective or not effective, right? Um, all right. Let's take a quick 10-15 minute break. 11:16 by my watch. Okay, we want to do one more question here. Let's do one more question, then another couple of minutes maybe, and then we'll take a break for 10 minutes, and then we resume by 11:30. So, okay. Um, okay, suppose I am conducting this survey, right? I'm conducting this experiment. Rather, it's not a survey, it's a controlled experiment. So I'm conducting the experiment. and I know, right, which people have got the active pill and which people have got the inactive pill. Right? I know that. Now I've got a research scholar who is say working under me, and I ask all these people to sleep in a sleeping lab. Why would I do that? Everybody sleeps in a sleeping lab.
Controlling the environment, lurking
Controlling the,
variable,
again, same thing, right?
like
Controlling the lurking variables,
surrounding.
controlling the environment so that everybody is having the same thing, right? Same scenario. Okay. Now I'm asking a research scholar who's working under me to kind of, or maybe a junior doctor, to measure the, or to see the number of hours that these people are sleeping. Okay. Maybe collect that data from them. Now, should the doctor or the research scholar know which people have got the active pill and which people have not got the active pill?
Should not know.
They should
No,
not know.
no, should not know.
Should not know. Why?
Yes.
Let's say
To
with
get
the
the unbiased
bias.
decision.
It might can it won't be the decision might can affect their decision, right? Should it can be biased also.
So there can be a biasness which is introduced by by this person knowing whether you've got an active pill or inactive pill, and while collecting the data, he might be biased about it. So we would not want that biasness to creep in, and since we don't want the biasness to creep in, therefore we would want to ensure that the other person does not know about it, right? And if he does not know about it, um, then whatever data is collected, that will be the probably the correct data. He would not fudge the data, and then things can be done in a better way. Okay. All right. Fair enough. I think other questions can be left out. That's all right. Important concept wise, I've covered everything. Fair enough. So let's take a quick 10-minute break. Everybody be back in 10 minutes, and 11:30 we start, right? 11:18 by your watch. Okay. So
Okay.
11:30 we
Okay.
resume. Okay. We'll start with a new topic now. We've done this. Now maybe moving more towards the statistical part now. Okay. So ensure that you're
Okay.
back in 10 minutes. Yes, are we back, everyone? Can you guys hear me?
Yes.
Okay. Sorry about that. I got a little late. No problems. We'll just stretch for 5 more minutes and we'll be good about it. All right. Where's the July batch? Okay. Anyway, fine. Let's quickly move on. So we have understood, how do we handle data? So if you have continuous data, if you have categorical data, I told you the way you handle those data would be different. And apart from that, we've also understood, you know, to the concept of population statistic, the concept of lurking variables, right? And few other concepts we've just understood, right? Controlled experiment surveys, all those things. How do they impact when you work with statistics? Very basic foundation of statistics I've kind of laid down, right? Now we'll move on to another topic, and that will be on, that will be on. Okay, by the way, the assignments to this chapter one, right, are present on Moodle. You can download it from there, and you should start working on those assignments. We'll be discussing that uh, in the next class probably, right? Okay, now we would want to understand about visualizing data. We're trying to move towards frequency distributions, right? And what exactly that is, we'll understand that in depth, right? Now, when you have data, any kind of data that you have, whether it is continuous data or categorical data, um, you would want to have a good understanding of the distribution of the data, right? Because suppose the data is in a tabular format, you would not be able to make much sense of that. Everyone with me on that? You would not be able to make much sense of this data, the data which is in this tabular format. Suppose this is the details of uh, people who are attending a conference and they come from, say, different countries. Now, if the data is in this current format, do you think you'll be able to make sense of this data? You'll be able to do a quick analysis of this data?
No.
No.
No, right? It's not feasible. So what you would want to do rather, you would want to ensure that you convert that into some kind of a frequency table. Okay. Okay. Um, yeah, so we'll convert that into a frequency table. And what happens in a frequency table? Okay, you'll have some variable, right? And then we obviously we value one, value two, some values to the variable. So until value n, right? So there'll be different values to the variable. And once you have the values to the variables, you'll have frequency corresponding to each of the variable, right? X1, X2, X3, so on till Xn. Okay. You'll have some variable and then you'll have frequency corresponding to that variable, right? Okay. So rather than directly working with the data, you would want to work with a frequency table, and a frequency table would, as I told you, will always be a better way to work with the data. Okay. All right. So frequency table, in this case, again, you can figure out how many times China is occurring, India and all those different countries are occurring, and you'll be able to draw a frequency table. Okay. All right. So that's the concept of frequency. What is frequency, by the way? I did not use it. What is frequency?
The number of time any variable has occurred.
Yeah, frequency is the number of occurrences of a given item, right? Number of occurrences. Okay. Then there's another thing called relative frequency. What is relative frequency?
It's the ratio.
Sorry. Ratio of
I
what?
mean, it's like for a particular variable, ratio of that frequency divided by the total number of
Okay, so relative frequency is
count.
your frequency corresponding to, or whatever the frequency of a given event with respect to frequency of a given event with respect to total frequency, right? Okay, so frequency of a given event E with respect to total frequency is my relative frequency, right? Relative frequency is also known as proportion. Okay, so proportion and relative frequency is one and the same thing, correct? So
Yes.
if suppose there were 100 people in a, okay, 100 people from India out of total say 250 people, so proportion of people from India would be almost 40%, right? And my relative frequency will also be 0.4, right? Relative frequency will be 0.4, proportion will be 0.4. So this is my relative frequency, this is proportion, and proportion into 100 gives me percentage, right? That everybody knows. Proportion into 100 gives me percentages, correct?
Yes.
Fine. Okay, let's quickly move on. All right, okay. So, okay, all proportions are always between or equal to which two values?
0 and 1.
0 and 1.
0 and 1, right? All proportions will always be between 0 and 1.
Right.
Yes.
Right? Okay. And for any frequency table, right? Suppose I have a frequency table, all the relative frequencies will add up to what value? On the chat window only. For any frequency table, all the relative frequencies will should add up to what value? On the chat window quickly. Yes, it should be 1, right? So all frequencies for a given frequency table, if you add each of the proportion, all the proportions would add up to 1, right? So same thing here also. Uh, uh, if you take a frequency table and you add all the relative frequencies, it will add up to 1. Okay. All right. That's pretty simple, straightforward thing. And I told you proportion into 100 will give you percentage. Okay. Fine. Okay. And percentages range from 0% to 100%, right? That also we know. No problem, sir. Okay. All right. Fair enough. Suppose this is the data for say 50 students. Suppose I have got 50 of different students who are taking some of my class. Uh, uh, and this is the age of those people, right? Uh, so for these 50 people, right? Uh, if I want to represent this in the form of a frequency table, uh, if you want to represent it in the form of frequency table, how many rows do you think you would need?
2 rows and
Total number of different ages we have.
can up to any rows, like it depends on how any way we want to group up.
Okay. So
It can be
suppose
up
if
to
I
n
give you
number of
these 5
rows.
options.
It can be 8 to 10 or it's second, it depends on how you group the data as well.
Okay, so how many rows we would need, it can depend on how we are grouping the data, right? That's one way of doing it, or we can just take one for each age. That can also be there. Now up to you how you want to do that, right? So there's no fixed number of rows that you would need to put in a data, but obviously if there are a lot of values which are missing, right? So you not want to put, say, a lot of values which are 0, right? That would not make sense. For example, I don't have 28 in this data set, for example, or I don't have 35 in this data set. I would have a row for 35 and not have a value. Would not make sense, right? So I would only want to take values for which I have data, and then I would do that, right? So that's one simple way of doing it. But yeah, the best possible way is that I would need that many rows on the basis of how I'm grouping the data, right? If I'm grouping the data based on groups of 5, so 0 to 5, 5 to 10, so on and so forth, whatever is the frequency for those group, I would get that. If I have values beyond that, then it would be something more, right? Correct? All right. All right. In this case, so what will be the frequency between 20 and 39?
$21.
It will be 21, right? How it is 21? 21.
So total number of students are 50. So total number of students are 50. It's like 21.
Yeah, correct. So total number of students are 50. That's true. Total number of students are 50. 19 and 10 is 29. Now 21 is remaining. So that is what should be part of this group, right? Okay. So overall it will be 50, right? Now, obviously this is not just the best way. So we would want to work on a histogram, right? So only knowing the frequency is not enough, right? You would want to only knowing the frequency, or having a frequency table is not enough. You would want to represent that in the form of a visualization, right? So whenever you are visualizing a single continuous variable, you can convert that into you can use something called a histogram, right? Let's try and understand the histogram a bit more in depth. So in a histogram, you have two axes. The y-axis will always have frequency. The x-axis will always have the variable for which the histogram is being drawn. Okay, and both of this obviously will be a continuous variable, as I mentioned to you some time back. Okay, so this x is a variable for which the histogram is being drawn, and it's a continuous variable, right? On the x-axis, you will have data, right? Suppose you'll be grouping the data on some based on some data, some values. So the groups that you create here, right? Each of this group is called an interval. This is called an interval, right? And the size of the interval is fixed. For a histogram, the interval sizes is fixed. Okay, you don't have intervals of multiple different sizes in a given histogram, or generally you would not want to have it. Okay, and once the interval size are fixed, or the bin size, this is also known as bin size. Okay, in interval size or bin size, that is fixed. So you have 0 to 10, 10 to 20, 20 to 30, so on and so forth, right? Different bins of same size, and you would have frequencies for each of the bin, right? Number of data points within each of the group, based on which the histogram is drawn. Are we good till this point? So few important things: histogram, the bin size is fixed, or the interval size is fixed. It is always for a continuous variable. Y-axis always has frequency. X-axis always has the variable for which this is drawn. And yes, uh, now we are having a histogram, right? There'll be a lot of other properties of histogram. We'll see that. Suppose this is a value. Say, let me take it as 10. Uh, Let me use another pen. Suppose this is 10. This value is say 8. This, let's take it as 15. Okay. Now, what is the interpretation if I just take this bin? What is the interpretation? This is one single bin, right? Between 0 and 10. What is the interpretation of this particular bin? It says that if you take in my data set, whatever I have, when I go from 0 to 10, there are 10 values which lie between 0 and 10, right? Similarly, between 10 and 20, how many data points exist? 8 data points exist between 10 and 20, right? Similarly, between 20 and 30, there are 15
15.
data points. Okay, and so on and so forth. Also understand, when you change the bin size, right? If you say I want to have a bin of size 5, now you can say I can have 0 to 5, uh, right? Another 5 to 10. But then the moment you have 0 to 5, 5 to 10, all the bins will be of size 5. Okay, it will not be of 7 or 10. You would have it all of them of 5, size 5 only, right? Same, you cannot have one bin of size 5 and the other bin of size 10 in a given histogram. Clear? Everyone, are we
Yes.
comfortable?
Yes.
Okay.
Yes.
Let's quickly try and answer a few questions. Yeah, any questions? No, we're good, right? Okay. Tell me which histogram has a smaller bin size?
The left one, green one.
Green one, sir. Green one. Left one.
Green one.
Green one, right? What is the bin size here?
Yeah, 10,
10.
10.
10, sir.
What is the bin size in this case?
20.
20.
20.
It's not 10, right? This is the entire bin. We are saying looking at the bin, complete bin, right? Each bucket or bin is kind of fixed here, right? So this is 20 and this is 10. Okay. What is the bin size in this case on the chat window only? Just quickly, last 10 seconds.
Sir, there is some background noise coming from somewhere.
Okay. I think we're good about it now, right? No background noise now.
Yeah.
Okay, so in this case, the bin size is 5, not 10. Right?
Correct.
Bin size is 5 and not 10. Okay.
Yes.
All right. Okay. So the bin size here is 5, and how do I know that the bin size is 5 here? What do? You take the starting point, say as 10, right? And suppose you're traveling from 10 to, just a second. Aisha, a bit of background noise from your end, so I muted you. Okay. From 10, if I move to 30, or say move to 20 also, right? Uh, if I move from 10 to 20, or if I move from 10 to 30, if you just, let's take it 30, right? So the distance traveled is 30 minus 10. That's the distance I've traveled. And how many bins have you crossed in that time frame? 1, 2, 3, right? 3 complete bins, and then half a bin here and half a bin here. Yes. So overall, you've covered 4 bins. So what will be the bin size? 20 by 4. And how much is that? 5.
Correct.
Yes.
Okay, fine. So that's how you can
Yeah.
find the bin size. Okay. What is the most frequent age? On the chat window again, what is the most frequent age? Yes, quickly, what is the most frequent age? Think about it. Give me a precise value. Okay, good, Rishikesh. Others quickly. Okay, Sandeep, thereabouts. Okay, fair enough. Good. So if you look at this, right, uh, we know this point is 10, we know this point is 15, right? And understand this, these are all in the center, right? It's not, you know, just anywhere. It's in the center of the bin, right? So 10 is in the center, 15 is in the center, 20 again is the center. So what will be this point? Now we are saying most frequent age is the bin with the maximum frequency, right? So this bin which has the highest frequency will be the one that everybody is comfortable with, right? That this bin which has the highest frequency will be the bin that we are looking at, right? The bin with the highest frequency, correct? We are concerned with this bin. Okay, for this bin, what is this point? This point is neither 20, right? 20 is just the middle of the bin. This point is 17.5 in between 15 and 20. And this point is between 20 and 25, right? 22.5.
Correct.
Okay, so between 17.5 and 22.5
Answer.
is my most frequent age, right? That's my most frequent age, 17.5 to 22.5. Okay. Okay. What proportion of students are over 60 years old? Quickly, 10 seconds for this. Yeah, so 5 by total is 50, right? 4 plus 1, 5. Above 60, you have 5 people, and below 60, you have another 45. So total it is 50. 50 by 5 will be, we saw, right, the data points earlier. So that's same data point, 50 people. 5 by 50 is 0.1. Okay. What percent of students are under 60 years of age? We know, right? It is pretty straightforward. So whatever remaining is 90% will be below. What if we wanted to know how many students are younger than 20? I want to know how many students or what proportion of students are younger than 20. How can I know that? Can you give me a precise answer to that? What proportion of students are less than 20 years of age? Less than 20 years of age, what proportion of students? Okay, more than 20%. Okay. Can we have a precise answer to that? Is it possible to have a precise answer there?
No.
You can't have a precise answer there?
No, sir.
Yes, why not?
Sir, because like we don't exactly know how many people are there between 17.5 and 20. I mean, we have given the number of people between 17.5 to 22.5.
Okay, what is the interpretation of 9? What is the interpretation of 9 here?
Number of people
And
between 12.5 and 17.5.
So there are 9 students whose age lies between 12.5 and 17.5, right? That's what we understand. Similarly, 17 is the value that there are 17 students whose age lies between 17.5 and 22.5. Do I know whether, I mean, what is the age of each individual? I don't know, right? If I just see the histogram, based on the histogram, all of those students can be aged 22. All of them can be aged 21 also. I have no idea, right? When I'm saying I want to know aged between less than 20, maybe all of them are aged 18. I don't know, right? By looking at the histogram, you can only talk about the edges of the bin. You can never talk about in between a bin. Okay. If you want to talk about in between a bin, what do we need to do? If you have to talk about in between a bin, what do you need to do? Quickly. We need to reduce the bin size, right? If I reduce the bin size, what will happen? Now I'll have frequencies till that point, right? See, if I've taken the data from 10 to 12.5, 12.5 to 15, 15 to 17.5, 17.5 to 20. So if 20 is at the edge of the bin, right? If it forms the end of the bin, then certainly that's pretty feasible, right? Correct? Then I would be able to know what proportion of people are less than 20 or greater than 20. Then that can be known, right? Everyone with me?
Yeah,
Okay.
correct.
With me? Any questions? No, right? We're good about it. All right. Now there's another thing called bar graphs or bar charts. What is a bar chart? What's a bar chart? Okay, a bar chart would be when you are working with a categorical data. Okay, so if you're trying to draw the frequency distribution for a categorical data, then you would end up with a bar chart. For example, if I have say US, India, say Germany, whatever, right? Then this is a bar chart, right? Now, what's the difference between a bar chart and a histogram, right? One straightforward difference I told you is that histogram is for a continuous data, bar chart is for a categorical data, right? What's the other important difference here? Like,
So the gap, there is no gap in the bar chart.
there's some gap. Okay. In a bar chart, now there is cannot be a continuous value, right? This is just a category. So I can say this is just the labels, right? Yes or no? So I
Histogram
can
is for
put
continuous
India
data.
here, I can put Germany in between, I can put US. So if I keep changing the positions of that, it won't matter, will it?
Yeah, correct.
Yes. The even if I put that here and there, it would not matter, right? US, India, Germany, whatever, right? Whatever data I have, if I change the position of the categories, it would not matter, right? Plus, if I get some shape out of this, right? If I'm getting some shape out of the distribution, the shape also does not have any bearing. There's no interpretation that you can do with respect to shape for a bar chart. Because since the values can change, the shape can keep changing, right? So you cannot have any interpretation on that. But if you look at a histogram here, a histogram, you'll have data in a continuous value, right? So it starts at some value, it moves up in the other direction. So you cannot have say 18 to 20 here, and you can say I'll have that only, right? So whatever you do in a certain order, the order has to be followed, and the shape of a histogram is a very important measure. Is a very important criteria. It helps you understand a lot of things about the data. Clear? Everyone with me on this? For a bar chart, shape does not matter. Here, shape is a very important area, important thing. Similarly, this the order would not be. It's for continuous variable. It's for a categorical data. Different areas, important pointers. Everybody understands that now? Any question? No? We're good? Any quick question? You need to be able to ask the question. Now it's a two-way interaction session, right? It's not a demo where you're not able to talk. Okay. All right. Now let's try and answer this question, everyone. Yeah. You have got a histogram on the left hand side. No matter the bin size, what is always true? Yes. Which of these statements are true based on the histogram that you see on the left hand side? You have certain statements which are made here. No matter the bin size, what is always true? Yes, quickly on the chat window, you need to answer that. Okay, most scores fall around 20%. True or false?
Yeah, true.
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 True, right? This is true. Most scores fall irrespective of the change in bin size. The shape is roughly symmetrical. As of now, it seems symmetrical, but if I change the data, if I kind of change the bin size, will that remain symmetrical or not? We'll see that through an applet, okay, later. So I'm just okay. This is I'm keeping this for pending. Most common body fat percent is 35%, so that's incorrect in the middle of the distribution. Yeah, as of now it's true. And even if I collate data, right, seems like third is false. Only the third is false. Second, we don't know. Fourth seems true. More scores between 15 and 25 than 35 and 50. That seems true. More scores between 0 and 10 than 18 and 24. 0 and 10 than 18 and 24. That's false. Literally, fewer men have a body fat percent above 35, so that's also true, right? So first, second, I don't know. Third is false. Fourth is true for sure. Fifth is true for sure, and seventh is true for sure. Second one we'll check with an applet. We'll try and confirm it. Okay. All right. Let's quickly move on. Okay. Then another important and then we move on to the next topic. Okay. One important quick example here, and then to the next topic. Okay. Now there is something called skewed distribution. Okay, and there is something called symmetrical distribution. There are two kinds of distributions. We'll understand about that in depth later on. Okay. All right. What is a symmetrical distribution? So if you have a histogram like this, right, where the about a certain center, it might not be the mean always, but yeah, the the data is like this. The distribution looks like this, and the distribution is symmetric about a certain point, and that's called a symmetric distribution. That's called a this is generally a normal distribution, normally distributed data. Okay, this is a normally distributed data. It's also a symmetrical distribution, which is symmetric about a certain point. Okay, symmetric about a certain point. This we'll talk about this in a lot of depth in in further sessions. Then there's another thing called a skewed distribution, right? A skewed distribution is a distribution which is not normal, which is not symmetric about the mean, so which can be skewed like this, right? So there can be a skewness like this, or there can be a skewness in the opposite direction like this. Okay, skewness can be either ways. It can be a skewness in one direction like this. This is a positively skewed data, positively skewed distribution, sorry. Okay, and this is a negatively skewed distribution. Okay, this is a positively skewed distribution. This is a negatively skewed distribution. Now let's take a quick example of a positively and a negatively skewed distribution. Um, Anybody who can think of a positively skewed distribution? So two variables for which we are trying to create a distribution, and or maybe one variable only, and you want to know yep. Okay, let's try and understand this. Suppose I'm trying to understand or draw a distribution between India's population or India's, population of India would be population of India. You need to have some parameter about it, right? So that's just a number of people, right? So if I say population with respect to income, okay, I want to distribute my India's population with respect to income. What will happen? So frequency on y-axis and income on x-axis. How the distribution would be? A lot of people will have zero salary, right? There might be a significant number of people with zero salary. Then there'll be a lot of people with lower salary. Then there'll be a lot of people with lower salary, right? And as you keep moving and as we reach a certain value, post which number of people with higher salaries will keep reducing, come to a point where it is near zero. Yes or no?
Yeah.
This is how the distribution would be. Agree? Right? Here I'm talking about the frequency, right? So number of people on y-axis, right? And income on x-axis, right? So this will be some median income. We'll talk about that. Right? This income is the income uh, for majority of the people, right? So maximum people have this income. If I go further, maybe the distribution is not just aberrant. It might come up like this. I mean, there can be various things here. I'm just trying to draw a distribution which seems skewed, right? Correct, everyone? This is a positively skewed distribution. If I take India's distribution population with respect to age also, how will that be? India is a young country, right?
Mm, yeah. So mm, lots of number of people in between 20-30.
Hmm.
It will be, I think, positive skewed distribution.
Okay, similar thing, right? India is a young country, so a lot of people are in the lower age bracket as compared to people with the higher age bracket. So as you move on the higher age bracket, number of people would reduce, right? And there'll be a lot of people who are in the lower age bracket, right? So which means, uh, yeah, which would mean that this is how it is, right? Okay. Then yeah, then take an example of a negatively skewed distribution. Anybody? Quickly, any example of a negatively skewed distribution? So age at death,
Yeah.
age at which
Yes.
people die. That'll be negatively skewed. So less people die at lower age, at a given value, fewer people dying in that age, right? So something like this, majority of people would die in a certain age, and again, beyond this also will be very few people, right? So this is again a negatively skewed distribution. So data can be positively skewed, can be negatively skewed based on the distribution. Again, there is interpretation based on that, right? Is the data is if the data is positively skewed, you'll interpret things in a different way. If it is positively skewed, you'll interpret that in a different way. We'll talk about the interpretations in the next topic. Okay. All right. I think we can leave out this question. That's all right. Okay. Let's move to the next topic, which is about measures of central tendency. Okay. Now moving to the third chapter. There are about 16, 17 chapters in this. Okay, we're talking about measures of central tendency. What is central tendency? Any idea?
Mean mode median comes under that.
Mean, median, mode, right? What is central tendency? So basically, why do you need to figure out a central tendency? Let's try and understand that. Suppose you have a set of variable, a given variable, right? Any variable x, okay, maybe speed, okay. Now, if you're going from point A to point B, right? From going, in going from point A to point B, you might have experienced lots and lots of different speeds, right? Say 0, 10, 20, 40, back to 10, 20, 40, different numbers, right? But to be able to represent all of that speed, right? Some numbers, right? I'm just taking some random numbers. To be able to represent all this data, you don't want to represent it with all these numbers, right? You say, let's try and see, let's try and represent all this data by a single value. Yes or no?
Yes.
You have a variable, you want to represent that entire data with one single value, and that single value is nothing but the central tendency. Okay, one value which is able to explain the entire data. Now, to be able to work with numeric data or even the categorical data, you can use different measures of central tendency. And there are three measures of central tendency, right? Central tendency is the central value using which you can describe the entire data. Okay, you have a set of values. With one single value, you want to describe the entire data. That's where central tendency comes into picture. Okay. All right. And there are three measures of central tendency. One is mean, median, and mode, right? I mean, we have mean, median, and mode. I'm sure some of you would have read about it. Some would have know this better, but that's all right. Even if you don't know about it, I'll just start from the scratch. So mean is nothing but average, which is nothing but sum of all the data points divided by number of data points, right? Okay. Median will be the value in the middle of the distribution. Okay. And mode is the value at which the frequency is highest. Okay, we'll see that with an example. Frequency is highest. Okay, everyone with me till this point?
Yes.
Yes.
Yes. Okay. All right, let's quickly move on then. So we've got mean, median, and mode, right? All right. Let's take another example. My notes. Yeah. So I've told you a few things. I've told you what is mean, what is median, and what is mode, right? I told you we're exploring that in lot more depth now. I told you what is mode. Mode is the value at which the frequency is highest, right? Value for which the frequency is highest.
Over here is 9.
9.
Over here it is 9.
Yes.
Yep. 9. 9 is what? The value at which the here 9 has a frequency of how much? 2, right? 9 is occurring twice. Correct? This is occurring once, right? All of that, the frequency is 1. The frequency for 9 is 2. So 9 will be my mode here. Everyone, mode is the value for which the frequency is maximum, right? the one which is occurring maximum number of times. Okay, let's try and take another example. Okay, in this case, okay, if you take these two distribution, one is the distribution of marks of computer science students, the other is electrical students. Their salaries, maybe distribution of salaries is given here. So in this case, mode will be a single number with the highest frequency, or it can be a range with highest frequency.
It will be a range.
It can be range. So mode can be a single value, as we saw in the previous case, and it can, when you're looking at a histogram, it can also be a range. Okay, mode can be a range as well. Okay, all right. So in this case, it can be a range with that occurred with highest frequency. Where does the mode occur in this case? Between which two values?
Between 60 to 80.
Between
60 to 80.
75 to 80, right? 75 to 80. That's
75 to 80.
that's the bin.
Yeah.
Okay, it's 75 to 80. This bin has the maximum frequency, so that is what it will be. Good. Okay, what is the mode in this case? On the chat window, take this as January, February, so on till December. Where do you think is the mode in this data? Let's try and see how good you are.
We don't have a mode in this. It's almost the same. Like pattern is almost getting same. We cannot.
Okay.
2-3 places we have the same data, so we cannot say the mode at one particular point.
Okay. Yes. Okay. So what kind of distribution is this? What kind of distribution is this?
Almost similar, like.
Sorry, go ahead.
Categorical.
Categorical. Okay. Okay. See, this is a uniform distribution. Okay. This distribution is a uniform distribution, and how does a uniform distribution look like? The value, even if you change the value on x-axis, the y-axis value does not change much, right? So y-axis, the value is more or less constant in this case, right? There's hardly any difference apart from couple of places. More or less, the value remains constant, right? So when you have variables in this way, when your y variable does not change with respect to change in x, we say that this is a uniform distribution, and uniform distribution do not have mode, as very correctly pointed out, because you don't have values with two values which are significantly different, or one value which is significantly higher. You would say there isn't any mode. At the end of the day, you want to represent all this data by a single number. Now, can you represent that with a single number across the month? If I'm looking at, say, what's the temperature for this particular, say, this is a temperature distribution, maximum temperature or average temperature for a given city, right? So if I want to represent all this data by a single number, what would that number be?
Yeah, it
Whatever
can
is
be
the value on
25,
y-axis, right?
26, 25, 26.
No, around 30, 28, 29, 30, some number. 25, I think it's a little lower on the end. So 28, between 28 and 30, any number would do, right? Because that is more or less
Right.
representing the entire data, correct? So
Hmm.
when
Correct.
you are trying to do that, at the end of the day, mood, mean, median, whatever you use, it's primarily to understand the data, to be able to explain the data, right? So we don't have to worry about whether it's a uniform distribution, what we do. So for a uniform distribution, the value is more or less constant, and that's what you can use, right? But there won't be any mode in that case. Okay. All right. In this case, histogram of adults' height in India. I've taken adults in India and they've taken their height. Now, what is the mode in this case? take each bin as that particular value. I mean, I know we talk about range, but for now, just take it as that single value.
So 5.6.
5.6.
5.6. How many of you agree to that? Anybody who does not agree to that?
5.6 only.
Okay. In this case, if you look at this data, now we thought that 5.6 is a good measure, right? That seems to be the mode here, right? But if you look at this data, basically, yeah. So it'll come to that range thing, Ritika.
Oh,
Yeah. So if you look at this, this is a normally distributed data. You see that there's normal distribution here, and there's another normally distributed data here, right? Not perfectly normal, but yeah, there's a distribution here as well. Whenever you look at data and you see multiple normally distributed data sets in the data that you are working with, that basically means that it is a multimodal distribution. Okay, which means the data set will have multiple modes. Now, if I'm saying what is the mode in this case? So this can be one mode, this can be another mode. Okay, there can be two modes in this data. But why would we need two modes? What is the purpose of having two modes? And why would we say that this data is a multimodal distribution? Just think about it.
It's specific to that distribution, like one more specific to that distribution.
Maybe if we want to consider some range of height, like in the case.
no, as the data is so much spread and
Okay,
distributed, so we have to take this one.
okay, let me
Maybe
try and explain
another
this to you.
parameter also coming into the picture. Maybe male, female.
Okay, good point. Very good point. So basically what is happening here is that we are saying that this is the data, right? This is the entire data that we have, adults data, right? Now, the data that you have basically has two distributions within it, right? Or the data set that we have can be divided into multiple groups on the basis of
A third parameter which is
some
not showing
parameter,
up
right?
here.
Third parameter, right? So it can be male, it can be female, it can be, I mean, maybe gender can be one parameter, location can be one parameter, right? So yeah, so any of that parameter, right? So when we say that you have a data set, and if you see that there is multiple modes, you can very safely assume that there must be at least one parameter on the basis of which the data can be divided into two groups or three groups or 10 groups, whatever number of modes that you see there. Okay, and in our case, maybe male female is a good way to look at it, right? So adults, if I'm taking adults in India, maybe male will probably have a touch high, or touch longer or higher as compared to female. So there, maybe one distribution is for male, the other is for female. Or maybe if you take, right, again, people living in hills, they have comparatively shorter heights as compared to people living in plains. Maybe there's some distribution of that, I don't know. So there is certainly some parameter on the basis of which the data can be divided. All right, everyone good with that? Okay, what is the mode in this case?
80.
Quickly, what is the mode in this case?
Republican. No, we cannot.
Okay.
We cannot predict into
Now,
this
very
because
important.
x-axis
Let me
no
explain.
values is there
Let me explain. I think you're
because
no, that's
frequency.
incorrect. Okay, no, hold on. Let me explain. See, if you look at this is frequency only, right? On the x-axis, you're having Republican 80 and Democrat 20, right? That's what we say, right? Now I want to find the mode. Basically, whenever you work with mode, more often than not, mode is used for categorical data only. Okay, the data that we have is categorical only, right? Republican and Democrat is a categorical data, correct? Why would you
Okay.
use mode for a categorical data? Because for other data, for if it's a continuous data, average can be found, median can be found, right? Mean or median can be found. But if it's a categorical data, you can neither find mean nor find the median. So if you want to find a central tendency for a categorical data, if you want to kind of showcase a categorical data, mode is the only way out. Okay. And again, in this case, the mode is Republican. Okay. I told you the value at which the frequency is highest. It's not the frequency. 80 is the frequency and 20 is the frequency. Right. So that cannot be the mode. Okay. Value at which the frequency is highest. So value is Republican. For Republicans, the frequency is highest. So that is my mode. So if I have a person whose data is not known, suppose one person whose data is not known, if I want to predict what could that be, I would predict that is a Republican because then my chances of being correct is much higher as compared to that when I do it for Democrat. Make sense?
Yes.
Anybody who is not able to follow, anybody who feels, we are going a little fast, I'm not able to understand what's happening, you can ask me. Because some of you have been a very silent listener all through the session, right? I'm primarily asking you people. We're good? Okay,
Yeah.
fair enough. All right, let's quickly take up the properties of mode. Yes, quickly true, false, 1, 2, 3, 4 on the chat window, 20 seconds. Yes, okay, enough time given. So the mode can be used to describe any type of data, right? Numerical, this is true. All values in the data set affect the mode. Is it true? Do all the value in the data set affect the mode? No, right? That's
No.
false. So if I change one data point does not mean that my mode would change. Correct? Okay, you can be muted, a bit of background noise from somebody's side. Uh, so yeah, so all values in the data set affect the mode. That's not
Uh,
true. So suppose I have a Democrat,
can you
80
explain
and
this
20
again?
is Republican. Which one? Take this point,
Yeah,
no?
all values. Yes.
I'm talking about the same point. So I'm saying 80 were Republicans and 20 were Democrats, right? Correct. Now, if I'm saying 21 is Democrat and 79 is Republican, does it make a difference? No, right? Or if I had another category, say this was 80, this was 20, and there's another category, say, which has, say, 5. Now I make it value which is in there, right? My mode still remains Republican only. Now you would say that it might be the case that one is 80, the other is 79. So if I change it, but in practical scenarios, it does not happen, right? Then in that case, you'd want to work with both these values if they're so close. Okay. So in real time, when you work with data, your data won't be, you'd work with say, thousands and lakhs of values, even millions of values. So then you don't worry about one single value, right? So then that situation generally does not arise. Okay. So that's why I'm saying it's not that all the values in the data set will affect the mode. Mode is affected only by certain few values. Okay.
Okay.
All right. Let's move on. So this is true. You got it right? Somebody was asking me, I'm not sure who asked that question.
Yes, thank you.
Yes, okay. If a lot of samples are taken from the same population, the mode will be same for each sample. How about this?
False.
False.
False, right? So if you take if you take multiple samples from the population, does not mean that mode will be same in all the population, in all the samples, right? That's very rarely true. So that's not something we'll take it. There's an equation for the mode. No, there's no equation for the mode. So this is also false. So only first option is true. Everything else is false. Okay. Fair enough. Now there are few good questions coming up. Basic median. Yeah, so few good, very good questions coming up towards the end. Maybe I think I'll not be able to take those questions today. Each question will take about 5-7 minutes. Okay, maybe we'll talk about the basics and then we'll talk about those questions tomorrow. All right, good. Uh, so mean, right? Now, mean everybody understands. Mean is the average, right? Average. And if you want to find the mean, you just take the summation of the values. You just take the average and you get the values, right? Okay. You can easily find the mean of this on Excel. If you're working, you can use the formula average equals to average and then you get the average. Okay, average will give you the mean. Everyone with me on that? No problems?
Yes.
Yes.
Yes. Okay. Then the properties of mean. Quickly try and answer this. The formula for mean, by the way, do we have a formula?
Yes.
Summation
Yes.
x upon n, right? So add up all the points, divide by the number of data points. Yes. So this is true, right? I already told you that this is true. All values in the distribution affect the mean.
Yeah, true.
True.
Yes.
True. Yes, all the
True.
values in the distribution will affect the mean. Okay. If you change even a single value, the mean would change. Different samples from same population have similar means. How about this one?
Yeah, true. True.
Can you explain? Somebody who's saying true can explain.
Yeah, because it
False.
has said the similar means, not the same means, I guess. But this is the only thing. It can
Okay,
have
one word
different
is saying
samples can
similar.
have similar means. Similar in the sense we have suppose we have taken three
Okay.
samples and it can be the mean for that can be similar, but it can't be exactly same, but it can be similar.
Okay. So again, we are not saying all the samples will be similar. Some samples from the population, right?
Yeah.
Majority of the samples say multiple samples from the same population will have similar means. That can be true, right? So again, we're using the word similar and not exactly the same. So there is true because again, if you take random samples from the population, considering each of the sample is a good representation of the population, so each of that will represent the population well. Their means will be closer to each other, and hence we'll say this will be true. Okay. The mean will change if we add extreme values in the data set. That also is true.
Yeah, true.
Ritika got it. You had put it as false, right?
Yeah, got it. Similar and same,
Got
right?
it, right?
Also.
Okay. Yeah, similar and exactly the same. These are two different things, right? The
Could you
degree is
please
different.
explain the last one?
Extreme values. So if I'm having say values like 10, 20, 15, 18, 25, and I add a value 500, what will happen? Whatever is the mean for these values, and if I just add this, it will have significant impact in the mean value. So this is an extreme value, right? An exception.
Yes.
Okay. So same thing. The mean will change if we add an extreme values to the data set. So it will change drastically, basically. Uh, there'll be a significant change is what we wanted to talk here.
Okay.
Okay. All right. Let's quickly move on. Okay, in this case, what is median? What is the median here? How would you find median, by the way? Okay, I think we're still talking about mean. So we have added an extreme value here, right? 50. So can you tell me what was the average earlier, and then what is the average after I add 50? Another 3-4 minutes, okay? No more delay. I mean, we extend the class 5-10 minutes. So so that should not be a problem, right? Just bear with me for another 5 minutes. Quickly, average for this, you don't, I mean, you can take the average for this. Average for this, it'll be how much? 10, 17, 24, or let's take it as 20, 30, 37, 37 and 8 is 45, 45 and then 46, 46.1 divide by 5, 9.22. Is that the case? Average of this is 9.22.
Yes.
Yes. And then you add 96.1 divided by 6. So 136 is 6, 16 point, 16.0, right? 0 and then 1. Yeah. Okay. Everyone, that's what. So in first case, before the extreme value, the mean was 9.22. After the addition of the extreme value, the mean is 16.01, right? So there's a significant shift in the mean value by addition of extreme value. You see that?
Yes.
Everyone?
Yes.
Yes, right? Okay. So the average, this average 16.1, right? Is that a correct value or is it misleading?
This is misleading.
Misleading, right? I mean, if suppose
Like,
you go to a college and you're trying to look for an admission, they say the average package is 20 lakh rupees, and you take an admission thinking that you'll get at least 15 lakh rupees. You see that most of the people get a salary of about 7 to 8 lakh rupees. You would be disappointed about it, right? So same thing, right? So you have some extreme value, some outliers used because of which the overall data gets shifted, and then you end up in a position where you think you kind of get up in, and get an incorrect value. Okay, uh, fair enough. So we'll start from median tomorrow. Uh, right. Again, a lot of things to be learned, and then we'll kind of talk about a lot of distributions tomorrow, right? All right. So those who've got the details, you've got the access to Moodle. On Moodle, you've got the assignments. The videos will be shared with you. You've got the notes there as well. Ensure that you go back and do the assignments. I'll be discussing the assignments to chapter 1, 2, and 3. Okay, latest by Tuesday. Tuesday class, we should certainly be discussing it. So I'm expecting that you complete the assignments by Tuesday. So take today's time, tomorrow's time, and from on the Moodle, you try and work with it. Okay. All right. Any other quick question?
no.
Yes, anybody has any other quick question? No, we're
Yeah, I
good
was
for
having
today.
one question
All right, guys.
with respect to controlling lurking variables, actually.
Uh-huh. Go ahead.
Uh, like in a given scenario, we could have n number of lurking variables. So, is it feasible to take each one of them and then control it? Does it work in that way, or?
No, so you try and control whatever is possible, right? I mean, when you really want a causal statement, I mean, that's why you see, right? When you have to do a research, you want to be very, very sure about it. So you ensure that you're taking care of all the lurking variables, right? Because you cannot
Mhm.
leave things to chance. For example, you're discovering a molecule, right? Consider a pharma company, and uh, if the drug is discovered incorrectly, whatever your effort is, right, it's all gone down the drain. So you don't want to take chances there. So a lot of such cases where you want to be very sure, you would use a pretty precise thing, but in general you can be okay about it, right? For example, if you take the road example, right, that I gave you. So when somebody says that the mileage of car is say 20.3, they very clearly put a star there and say this is in certain test conditions. So in certain conditions,
Mhm.
this is what you get. If you don't have those 10 test conditions, the value would vary, and we are okay about it. Yes.
Yeah, okay, yeah, correct.
Right. So certain amount of accuracy is fine. In such cases, we are okay. If you are looking at more accuracy, pretty precise thing, then you would obviously be you know looking at different things.
Okay, yeah, thanks.
All right, makes sense. All right, guys. Thank you. Aarti, pretty. I'm not sure. Is your mic working now, Aarti? Aarti there? Yes, no.
Yes, it's working.
This so again, lot of disturbance. If noise, then your voice. So please ensure that you get this sorted. And again, you were a pretty silent spectator today, right? So I would not want that in my class. Try and be more participative, right? So that you can learn. And we're still just, and doing only basic stats. There's so much more to be done. So the more you participate, the better you learn, right? So it's important that you do that. Okay. Even if you're not able to talk, try and answer on the chat window as much as possible. Okay. All right. Niharika, again, you did not participate much, so you need to do that. Others were more or less good. So, but everybody, right? Divya Lakshmi, again, hardly any participation in the class. Try and be more participative. Anish, no participation again, right? The more participation you have, the better is your learning always. Okay. You need to feel yourself involved. You need to be proactive. You should show that urge that you want to learn. There'll be effort from my side all the time. Okay, fair enough. So logging off for now. See you guys, tomorrow.
Okay,
Okay.
thank you.
All
Thank
right.
you.
Bye bye.
Thank you.
Thanks. Yep. Yep. Take care. I'll give you a new meeting ID for tomorrow. Okay.
Yeah, sure.
Okay.